Hello, everyone, and welcome to day 2 of Technology Updates in Energy Efficiency webinar. We started yesterday from 9. It was such a value-adding session. For those joining us today for the first time, welcome. For those rejoining from yesterday's session, it's an absolute pleasure to have you join us. Thank you so much. Today we are going bigger and better. This is the final day of this webinar. Again, this webinar has been brought to you by the World Energy Day Secretariat in partnership with UNREA, the Uganda National Renewable Energy and Energy Efficiency Alliance. They were here with us yesterday. They are here with us today. We had such a great opening remarks from Isaiah. And it also has been brought to you by IEPA, Institute of Energy Professionals in Africa, who are the official representatives of the international certification body AEE here in sub-Saharan Africa, and they do offer certification courses for energy engineers. And today we do have one of our speakers being a trainer from IEPA. And just a recap, yesterday was excellent. We had 4 topics, 4 speakers. We looked at technology updates in the real-time monitoring sector. We went to pipe insulation. We then went to compressed, and finally on water chillers. So today we have 4 topics and speakers as well. And before I unpack the lineup we have today and the conversations that our topics are anchored on, just a few housekeeping rules. We love an engaging audience, but we also love order. So we kindly ask you to mute yourself throughout the training. And if you have questions, we do have pockets of Q&A during the training where you'll be able to ask questions to the speakers and to the moderators. Feel free to utilize the chat option, which will be open throughout. And also, you can also use the raise hand button and we will be able to spot you. We do have a chat master, so do not feel shy to use the chat today. We also encourage you to have your videos on if you're comfortable. It's quite unnerving to speak to black boxes. So in this new era of online conversations, it's great to have your video on, and looking forward to a great start. Before I go on too much, let me introduce myself. My name is Liz Nyukuri. I'm an energy engineer here at Innovators, a part of the World Energy Day Secretariat, passionate about all things sustainability, green energy. So excited to be your moderator today. And before we go on, the topics today are revolving around what are energy service companies, what about financing, what about energy management standards, and a special towards the end on motors. So before we proceed, we do have a quick poll. We would like to ask Ruth, our tech support, to share it with you. And you can give us your comments on the barriers that are hindering the growth in energy efficiency adoption in Africa. It would be lovely to hear your thoughts on this. So feel free to submit an answer. We shall leave this on for a couple of minutes and have you give your opinion. For those joining us, welcome. It is such a pleasure and a delight to have you join today. A little more. Again, we are just saying that the World Energy Day 2021 is in such high gear. We are heading to Kampala, Uganda in October, and you do not want to be left on joining the team that is calling action. Our theme this year is on energy sustainability in Africa, unlocking the food and climate change equation. We are championing efforts that harmonize all this, that look at all these aspects. And we are calling on to you, for the stakeholders on the call today. If you'd like to be part of our sponsors, we'll post a link on our World Energy Day website where you're able to see the different packages that are there. And I believe by now we've been able to submit our opinion on the poll. I'd now ask Ruth to share the results. And there we have it. Lack of financing seems to be topping at 47%. We have unfavorable policies, energy management standards at 31, lack of awareness, and finally, human capital incompetencies. Thank you very much for sharing your opinion. Then you are in the right place today because we have speakers aligned to all these topics today, and it shall be. And we thank you for your feedback. Again, yesterday, in case you missed it and you'd like to catch up on the presentations that were there, we do have a WhatsApp broadcast where all this information on the speakers, the presentation, and updates on future events of the World Energy Day shall be posted. So once again on the chat, we'll have a WhatsApp link to that broadcast where we will be sharing all this information. So thank you again for joining us. I will now go on to our first speaker. He is in the house, and his bio, I will need more time than what I have been assigned to. He's a certified energy manager, a certified measurement and verification professional. He is currently a licensed Class A auditor in Kenya and an ISO 50001 energy management systems lead auditor and implementer. He currently works at the Kenya Bureau of Standards as a principal standards officer. He's now responsible for managing, developing of renewable and energy management standards. So he is the perfect person to handle the topic on energy management standards and ISO certification in Africa. His name is Alex Mboa. Hello, welcome.
Oh, thank you.
Great to have you here today. We are more than excited to listen to you. Take it away.
Thank you, Liz, for that wonderful introduction. I will, let me try sharing my, just a moment. I need to exit the full screen. Let me share my presentation.
Excellent.
Yeah, just a moment.
Great, we are able to see your screen.
Oh, you're able to see my screen?
Yes,
thank you.
Yes, you may go ahead, thank you.
Yeah, thank you. Welcome, participants. As you have heard, my name is Alex, and I work with the Kenya Bureau of Standards. I've been there for a period of about 10 years now, more than 10 years actually. So I've definitely overstayed, going by the Kenyan standards. Yeah, the presentation today is tailored. I'll just give a brief introduction of my employer, then we'll discuss some of the existing, already published energy management standards. And then in that part of the presentation, I'll also give you a highlight on how our standards are developed, the process of developing standards. Then we will dwell more on the ISO 50001, the 2018 edition, because this is a standard that gives guidance on setting an energy management system. As you'll appreciate, the region, especially Kenya, people have been doing energy management, but more so in an ad hoc manner. And the next frontier perhaps is now to have a systematic approach whereby the energy management is done in a more systematic manner. So with that, we have a tool or a guideline, which has been developed by ISO and has been adopted by Kenya. This document will discuss some of the requirements, then some of the benefits of having the energy management system. Then I will briefly take you through the process of implementation, some of the steps in implementing an energy management system. And finally, if you desire, because certification is always an optional process of getting the certification. just like the QMS ISO 9001, you can also be certified to an energy management system. So KEBS is a government agency, and we were established way back in 1974. We drew our mandate from the Standards Act, CAP 496, and this mandate gives us the following responsibilities. The first responsibility is standardization, and under standardization, we are given the responsibilities of developing standards and also disseminating the information on standards. So our standardization can be defined as the process of developing and implementing standards. So it has those two components, and we deal with them as well. This is because KEBS is an integrated, we have an integrated quality infrastructure. If you go to other more developed markets, you'll find that you have a standards body that develops standards, and then the other entities that do the conformity assessment services. So we also do the conformity assessment services, and the purpose of the conformity assessment purpose is to establish whether the goods and services conform to the existing standards. So here is where you have the inspection of imports, and also we have inspection of export for those people who are exporting out of the country. We also do certification. Under certification, we have two types of certification. We have actually we have like three. We have started also the personnel, where we are certifying welders at the moment. We also do product certification. I think this is the one probably most people are familiar with. You see some of our quality marks in products that are sold within the Kenyan market. We have marks for locally produced goods, and then we also have for those that are coming from outside the country. Testing, we do also offer testing services to establish whether those goods comply with existing standards. So our labs, they test a whole range from food to chemical to electrotechnical products, and also some of the renewable energy product. We also carry out market surveillance. Market surveillance is carried out to ensure that the goods that are actually in the market, they conform with the existing standards. Then one of our other mandate is the training. We do training. We house the National Quality Institute, and the main purpose of this institute is to raise awareness and train people on matters relating to quality. We also train people on practical application of standards. And finally, we have metrology. We house the National Metrology Institute at our place. And we majorly dwell with the industrial metrology, whereby we calibrate equipment. And you know, it's a legal requirement that when you equipment that are used for industrial purposes, for production purposes, they have to be calibrated. So some of you, especially those dealing with the measurement equipment, I think you're aware of the importance of having calibration or your equipment calibrated. So we offer those services as well. Then what is a standard? And generally, you can define a standard as a specification or guideline that outlines the safety or performance requirements for products and processes or services. It's normally developed and it encompasses the following principles: the principle of openness, whereby the participation in the process of developing standard is open to all stakeholders that are interested in the aspect that is being standardized. We also have the principle of transparency, in that we inform the stakeholders of the need and the standards that we are developing. So the process is open, and in case you want any information regarding development of a particular standard, you can be able to get that information. The standards development process is also based on consensus, and consensus means that when the stakeholders come, because as KEBS, we normally give the stakeholders a platform where they discuss the technical details of a standard. We normally prefer that there is consensus. That means there is agreement. We build consensus within the committee, not necessarily unanimity, but consensus can be defined where there is no sustained technical position to a particular element or a particular clause of the standard. Then the other principle is coherence, and coherence comes in because a standard is not a standalone document. We exist within a legislative and legal regulatory framework, whereby the standard is supposed not to contradict existing standards or existing regulations and legislation. That's the coherence we are talking about. So you have to have a coherent set of standards that it does not contradict existing regulations and other legislation. So the other one, which is not indicated there, is the principle of impartiality, whereby we treat all stakeholders with the same. We don't have what you call super stakeholders. Every view is important, and once you are a member of the technical committee, then you are given an equal chance of expressing your view towards the development of the standard. Normally, the standard development happens through a technical committee, which is normally constituted. It involves stakeholders drawn from the wider sector. For example, in the energy sector, you have the NGOs, you have the energy auditors, you have the industry association, we have the government agencies, all those consumer protection agencies, they are normally represented in the technical committee. So for the energy management, the TC responsible is called the Technical Energy Management Technical Subcommittee. And so far we have about 30 members drawn from various stakeholder categories. And we encourage people, if you are interested in participating in the standards development process, you can visit our website, then you can apply to be a member of that technical team. The process normally involves these stages that are listed. Preliminary stage is where you define and address the need for developing a standard. Here is where you evaluate the economic relevance. What impact will the standard have? Because a standard is an expensive in terms of cost and the resources that that are needed. You need the expertise. People are busy, so we don't need to put people in a technical committee developing a standard that will just sit on the shelves. So once the economic relevance has been established, the standard is normally moves to the committee stage. This is where majority of the work happens, and this is where the expert, they try to build consensus and arrive at requirements or text that is agreeable to all parties, and actually it meets the need of the standardization need. Then at the public review stage, this is a mandatory requirement whereby we give the stakeholders not already involved in the technical committee an opportunity to comment and give us feedback on the document. We circulate the document for about 60 days. They give their input. Then the committee will come and discuss the comments received from the wider stakeholders, and then respond to the stakeholders who raise their comments. So the public review stage, the comments are resolved. And if the standards meets the set criteria, then it can move to the balloting stage. The balloting stage is where the ownership of the document happens, and where the technical committee actually they own. Now they ballot. They say, okay, we approve this document the way it is. And if the committee agrees or it meets the criteria at that balloting stage, then it moves to the approval stage. Here is where the National Standards Council now approves the document for gazettement or for to be published. So in brief, this is what a standardization entails. That's the process of developing a standard. And At the moment, the energy management rests within the Renewable Energy and Energy Management Technical Committee, KEBS TC 92. The technical committee has about 5 subcommittees, and the energy management is subcommittee 4. And this is the one that is responsible for developing the energy management standards in the country. So far, the committee has developed a number of standards. We are about over 20 standards have been developed. And the development is you can either adopt an international standard, and the others that we have developed from scratch using reference from other jurisdictions. One of the standard, the key standard is ISO KS. ISO. If you see the KS ISO 50001, for example, it means that this document has been adopted from its equivalent to the ISO 50001, the 2018 edition. So as I spoke earlier, is that you can either adopt or adapt a standard to suit our local needs. So the energy management system requirements with guidance, this is the one that gives the requirements for energy management system. Then we have another standard which gives requirement, the general requirements for energy audits, conducting energy audits. Then we have the ISO 5003. This is a document that gives requirement for bodies providing audit and certification of energy management system. So in case you are seeking to have yourself certified for an energy management system, then the certification body which will do that work has to comply with this particular document. Then there is the 50004. This one talks about the guidance. It gives guidance on how you can be able to implement an energy management system. And it has some good material there. You can look at them if you get hold of the document. Then there is ISO, the KS ISO 50006, the 2014 edition. This is a document that gives information about how you measure energy performance using baselines and also energy performance indicators. So it gives guidance on coming up with energy baselines and also energy performance indicators. Then there is the KS ISO 50015. This one talks about the general principles of measurement and verification. Then the next one is the technical specification 50008, which talks about building data management. So it gives guidance on the kind of data that you need to collect and how to manage it, especially for those ones that might be having building management systems. Then there is another one, the KS, the ISO 50007. This one talks about requirements for energy services. So the guidelines for assessment and the improvement of energy service to users. So this one is applicable to the users and also the energy service providers as well. Then there is another document, this is the ISO 50021, which talks about, gives guidelines on selecting energy saving evaluators. So if you are organization or you are, as an individual consultant, you're advising somebody on evaluation of, on how to select and evaluate energy saving evaluators, perhaps this is a good document to have in your library. Then there is a very good document here, the ISO 50046. This one talks about the general methods for predicting energy savings. And for energy auditors, I think it's a good document to have because it gives you some of the methods of predicting energy savings. So it has some case studies and also gives you on how to treat uncertainties associated with the predicting energy services as well, energy savings as well. Then there is a document for assessing compressed air energy efficiency. This is the ISO 50000, 11011. And these other three, they are about the energy performance of lifts, escalators, and also moving walks. Then there is these documents that talks about, it gives a common understanding. This is the ISO IEC 13273, part 1. Talks about, it gives definition and defines the terms, the common terms that you find in usage when talking about energy efficiency. So they also have some other specific document about energy audits. This one talking about the processes, and the one that is particular to buildings and commercial buildings, actually, in this case. So those are some of the standards that have been published so far. And in case the stakeholders in this workshop, they feel that there's an area that we need to develop our standards, we also take information from our stakeholders. You can visit our website, and then you can also suggest, just fill a form and suggest an area where you feel that we might, where there is a gap in terms of standards. Now, the next session is we'll try to have an overview of the ISO 50001. And the key aim of this section is that we develop an understanding of the structure and have a rough idea of what the standard contains. First, we'll define a few terms that are very key when you are talking of management systems, and especially now the energy management system. We'll start by defining what we mean when we talk of a management system. In this case, the management system can be defined as a set of interrelated or interacting elements of an organization. And it's used to establish policies and objectives and processes to achieve those objectives. So it has about 3 components. So you provide that framework whereby you have a policy, then then you have a set objectives and targets, and then you establish processes that help you in achieving the objectives. Now, an energy management system is a management system that is used to establish an energy policy, energy objectives, energy targets, action plans, and processes that will help the organization in achieving the objectives and energy targets. So that's in brief what we mean by an energy management system. So it's a management system that allows you to establish energy policy, objectives, targets, action plans. This is where you have the control aspect then, and also monitoring the performance. How have you achieved the objectives, and what corrective action you need to take. The development of the ISO 50001 is, the document was developed by ISO, the International Organization for Standardization. ISO standards are also based on consensus, and they are normally developed through technical committees, or in some cases where there is no technical committee existing, then they also have project committees. ISO TC 301, Energy Management and Energy Savings, is a TC responsible for developing and maintaining ISO 50001. Currently, this is the 2nd edition, which replaced the first edition, which was the 2011 edition. And the 2nd edition adopts what we call a high-level structure, which is recommended for all the management standards. So the rationale for having a similar structure for all the management system standards is that it helps organizations in having an integrated management system. For example, if you already have an environmental management system in place, you can integrate with an energy management system, or you can integrate an ENMS with a QMS already, if the structure is the same. Some of the intended outcome of developing this standard is to enable organization to follow a systematic approach in achieving a continual improvement of energy performance and the ENMS. So when you're talking about ISO 50001, the key thing that you are supposed to take is that you have 2 aspects where you are monitoring the performance. first of all, the most important one, there is the energy performance. And then the other one is the energy management system itself. So when you're evaluating or you're assessing or you're implementing the energy management system, you are supposed to assess whether those two aspects have improved. You monitor those aspects and see whether it gives the intended outcome. See, sometimes the organization can have a wider outcome than the one that is given above. For example, your outcome might not be the energy performance improvement, or you might be concerned about energy costs. You might be concerned about improved reliability, and you also might be concerned about increased use of renewables within your facility. So those are some of the other intended outcomes of implementing an ISO 50000 based energy management system. Why implement an energy management system? For example, why should we implement an energy management system? So the first thing that comes to mind is, I think for those who have been conducting energy audits with the organization, there is what we call institutional memory. Sometimes when you are doing energy management in an ad hoc manner, you find that the energy champion maybe leaves the organization, moves to another place. So if you didn't have a system in place, then you'll have a problem because all the institutional memory has gone. So you need now to start again from a clean slate. But if you had an energy management system in place, then you can be able to survive a key member of your energy team leaving your organization because the systems are in place. All what remains is just training and the new employee on how to go about doing things. So the standards allow you to have a systematic approach to energy management, whereby the key aspect is that you are able to improve your energy performance in terms of consumption and related use. Then you can also reduce your cost, your energy cost. You can also meet your climate change goals. Also, you have improved reliability. You can also increase the use of renewable energy in your premises. Another key thing that normally people benefit from implementing an energy management system is once you get the certification, for example, you stand out. So it's a differentiator with your competitors, and you can be able to show that you actually are responsible corporate by managing your carbon footprint. So the recognition comes in, you stand out, there is cost savings, there is energy savings, and many other things. So it's important that you consider the systematic approach towards managing your energy resources or energy consumption. The scope of the standard, the ISO 50001 is actually applicable to all types of organization. How is that so? You can say because it allows you, the organization is the one that you set your own targets. For example, if and your targets and objectives, and then you also put in place measures. So the system you put in place has to be commensurate to the size and the resources that you have. So the key thing is that you have to show that there is continuous improvement in your energy performance and also the performance of the energy management system. The other aspect is that the document can be used as a standalone document. It can also be integrated with other management system. For example, if you already have an environmental management system in place, then it's easier for you to integrate the document within the other management system standards as well. So The rationale here is, of course, you have people already who understand, for example, internal audit processes. They understand the management standards way of doing things. So when you bring in the energy management system as well, then it becomes easier, and the process of implementation, it becomes a little bit shorter. So the key thing is that you cannot exclude any energy that is consumed within the facility. So if you decide, for example, to implement the standard, all the energy that is consumed within the scope and the boundaries of the organization has to be form part of the scope of the document. So the structure of the document is that the ISO 50001 is based on the Annex SL, and this Annex SL, don't mind about that abbreviation. The document is actually called Annex SL, and the Annex SL gives guidance on developing management system standards, and it provides a high-level structure for the management system standards, whereby the clauses are the same. For example, you have 10 clause high-level structure for each of the management system, even though you might have some differences here and there, which I will highlight in the next slide, between the ISO 50001 and the other clauses. So the rationale again here is that it makes it easier to work with more than one management system. So if you have all of them following the same structure, and also following the same common text in some areas as applicable. So the structure of the ISO 50001 is highlighted here below in this diagram. So you have clause 4 talks about the context of the organization. And the rationale here is that you're supposed to understand your organization before you start implementing an energy management system. You're supposed to understand the context of your organization. You understand the needs and expectations of your interested parties. For example, one of the interested parties might be the regulator. What does the regulator requires from your organization? Your investors might be part of part of the interested parties. Your employees, those are part of your interested parties. So you understand their needs and also their expectations. Once you do that, then you can be able to determine the scope of your energy management system. So if you, for example, you have an organization with multiple facilities, does the scope of the energy management system cover all the facilities or just one facility? That's the scope, and also define the boundaries of the management system. So once you have done this, all this is done with an understanding that there is top management support. And normally for those people in the energy sector, we insist about the policy and top management support in some of those activities. So all this has to have the blessing of the top management of the organization. And the clause 5 actually gives some of the things or the requirements that top management has to provide in the process of establishing an energy management system. So there's the leadership and commitment. For example, setting up the energy management team, providing the resources that are needed when you're implementing the energy management system, because you'll have the objectives and the action plan, which require financial support. The other one is communication. The top management has to communicate and raise awareness about energy performance and the ENMS throughout the organization. So that's one of the areas where the top management comes in. And also the energy policy. Is the energy policy aligned to the objective, the strategic objective of the organization? So this clause gives you guidance on what the requirements of the energy policy should be. And then there is organizational roles, responsibilities, and authorities. Now, in this case, you're supposed to define them. For example, the energy team, how is it constituted? What are the responsibilities? Have they been done? Such and such similar issues. Then the main clause, which talks about now planning. And this is where you do the energy planning, for example. How do you, have you identified the risks and opportunities that exist once you understand the context of your organization? Then thereafter, you'll be able to set your objectives and targets and how to achieve them. And then you conduct what is called an energy review. Now, the energy review and these other grays, these are the only found within the energy management system. The ones in red, you can be able to find those clauses with all in all the other management system standards. So under the energy review, you're supposed to understand your energy sources, historical energy consumption. Then you identify your significant energy users. You also identify, once you have identified your significant energy users, you go ahead and identify what we call the relevant variables. What variables affect your significant energy users? From there, you are supposed to set energy performance indicators. And it guides you on how to go about it. And then thereafter, you also develop what we call an energy baseline, and also given guidance on how to go about it, developing the energy baseline. And then finally, planning and collecting energy data, which is also key because you'll be monitoring the performance of your energy performance, also the performance of the energy management system. Then clause 7 is the support. What kind of resources are required to be given? And talks about competence, how to go about building the competence that is needed. Then there is also awareness, and then communication. And then there is documented information, what kind of documented information that is needed to be kept. For example, the process of energy review, you have to have a methodology on how to go about energy review. You also have to document your energy baseline, because your energy performance indicator, some of the documented information that is needed to be kept. And then the other one is the control of documents, because these documents are key and crucial. Then you are supposed also to have a means of controlling their usage. The other one is the operational control. And this one comes in once the action, what you need to do. For example, your procedures, especially those ones that affect the significant energy users, they need to have some form of operational control. SOPs on how to go, and do those SOPs take into consideration energy performance? This is where you get that guidance on how to go about it. Then the additional clauses with respect to ENMS is the design. Do you consider energy performance in your design activities, or when you are doing a modification in your facilities? And then the other one is procurement. Is energy performance a key? Do you inform your suppliers that energy performance will be used as a criteria to evaluate the product or the energy equipment they are offering? This one is actually required for those when you are procuring products or equipment that are significant energy consumers. So you have to have energy performance a key procurement criteria. Then the other one is this clause that talks about performance evaluation, because you have to monitor how well you are doing. So you have the internal audits, also management reviews as well. So under performance evaluation, you evaluate two things: the energy performance and also the performance of the system itself. So those are the key things you're supposed to take note. Then there is also now the continuous improvement, whereby after non-conformities have been detected in performing internal audits, how do you go about correcting them and ensuring that they do not recur? So the whole standard is based on a risk approach, and that's why in my presentation I've insisted on significant energy users. Actually, that's where you're supposed to put in more effort, because that's where those are the key equipment that can affect your energy performance or the energy performance of your system. Then the next one is the PDCA cycle. So the standard is normally based on this PDCA cycle, the plan, do, check, and act cycle. As you can see, you have to understand the context of your organization, internal and external issues, the needs and expectation of interested parties have taken into consideration. Once all those have been taken into consideration, then you have the intended outcomes of the energy management system. So under the planning, we have to understand the context of the organization. You establish an energy policy and an energy management team. You have to address what we call the risks and opportunities. You conduct an energy review. You identify significant energy users. You establish energy performance indicators, energy baselines, objectives, targets, and also develop the action plans to achieve those targets and objectives. Under the do, this is where you implement your action plans, operation and maintenance controls, communication. You ensure that you have developed enough competence. You also consider energy performance in design and also the procurement aspect. Under the check, that's where you're monitoring now. You monitor, measure, analyze, you audit, and you also conduct management reviews. Act is when you are supposed to address the non-conformities and continuously improve your energy performance and the ENMS. The energy planning process envisioned under the ISO 50001 can be viewed in two levels. First of all, you have the strategic view of the energy planning. Then there is also the tactical view of the energy planning. So the planning inputs under the strategic level of planning, you have the internal and the external issues. Once you've understood the context of the organization, those are the inputs that you'll have in your strategic planning. You also have the needs and expectations of interested parties. The planning, what you're expected to do under this stage is you are to identify the risks and opportunities for your organization. Then the outputs for this particular exercise is normally the actions to address the risks and the opportunities. Under the tactical review, planning, under tactical planning of the energy, you have the planning input is current energy types, past and current energy uses, past and current energy consumption. Then you conduct the planning aspect. What you're supposed to do is you conduct the energy review based on the energy consumption. Then you determine your SAUs. So you have to have a criteria, for example, for determining your significant energy users. You might say that those are the processes or equipment that consume, for example, 80% of the energy consumption in the facility. And when you are defining the SAUs, they don't necessarily have to mean that those are the equipment or processes that consume the most energy in your facilities. They can also be those processes or equipment that gives you the more opportunities for saving or improving your energy performance. So once you have done this, then you are supposed to determine and prioritize your opportunities for improving energy performance. And the output in this case, you have the energy use and consumption trends. You have an estimate of your future energy use and consumption. You have opportunities for energy performance improvement. You have identified your SAUs. You have your energy performance indicators. You have your energy baselines. You have your energy objectives, energy targets and action plans, and you have an energy data collection plan in place. So this is what you're supposed to have after you have conducted a comprehensive energy planning process that is in conformity with the ISO 50001. The next section, we'll just briefly talk about the implementation process of the ISO 50001. The process can be viewed in 3 stages. The first stage is actually determining where we are. Then the other one is now, once you have assessed where you are, you implement and operate. And then finally, you manage and improve. So under this, the first stage, what you're supposed to get, you are supposed to establish top management interest in establishing the energy management system. Then you also understand requirements of understand the requirements of the standard, legal requirements, and also other interested, the expectation of interested parties and such. Then you conduct the baseline review, you develop a Gantt chart, then you do resource mobilization, the resources required, then you approve and communicate the implementation plan that you have developed. Once you have developed that implementation plan, then you are supposed to implement, monitor the project, and give the project enough resources. So finally, managing and improving, where you are monitoring the performance of your energy management system and also the energy performance of your organization. So some of the steps that you might take through this process, if I go by listing, you might start by obtaining the top management commitment. Then you identify your organization's purpose, because you have to align. Normally you have the strategic objective of the organization. So you have to align your ENMS objective to your strategic objective. Then you form the implementation team, which will help you do that. Then get the standard, understand the requirements of the standard. Then also now identify your business processes, because each organization is unique. So you have to understand your business processes as well. The business processes you need to, the core business processes, the reason why you need to understand them, because you need also to know how to integrate the ENMS into your activities. So if you don't understand your business processes, then you might have a challenge in implementing the requirement of the standard within your processes. Once you've done that, then you are supposed to just have a list of all the required documented information that you are supposed to have. Then you might conduct what we call a gap analysis. Thereafter, then proceed with the other aspect of the implementation. You define the scope, now put in the control operational controls for the significant energy users after you have conducted the energy review and such. So some of the implementation costs that you need to consider when you are planning to implement an energy management system is the certification body, because they will give you a fee, they will charge you a fee to review your document or to offer the certification services. Then training, you might need to train, especially internal auditors. You also need to raise awareness on the ENMS. And then energy audits, because an energy audit can inform, an energy audit is different from an energy review as envisioned in the ISO 50001, but it can provide information that is useful in conducting an energy review. So you plan for that, either you going for external or internal use of energy auditors. Then you can also consider whether you'll use an in-house implementation team, or you can acquire the services of a consultant who will be able to guide you in implementation of the standard. Then there are also some of the internal costs, like associated with the time, man hours of your staff that are involved in the process of implementing and doing all those activities that we have talked about in the previous slides. So those are some of the costs that you need to consider. Here is a sample project schedule, and this one is for just illustrative purposes only, and they can be able to give you an overview on how to go about planning an energy management system implementation. So within the first 2 months, you can do what we call training and do planning. And then you define your ENMS and conduct the gap analysis to see which gaps you have, because once you have understood the needs or the requirement of the standard, you can try and gauge which requirement of the standard you already meet. That's the purpose of the gap analysis. Then within 2 to 3 months, then you can develop the required documentation. Then you can also start thinking about the certification body that will be able to, if you are going the certification route, and then you initiate the implementation process. Then within 4 to 5 months, you already implementation, then the ENMS is in operation, then you already started collecting evidence and documenting evidence. So within 7 to 8 months, then you can initiate what we call pre-assessment certification. This is what normally the certification body will give you a form, and then you fill to assess where you are with regard to the implementation. Then you can also start conducting what the internal audits to evaluate the processes that you have already implemented. At this stage, you also expect that you start conducting management review and taking the necessary corrective actions. And then during this month, 8th to 9th, then you can initiate what we call stage 1 audit. And this one is where the certification body will come and conduct an assessment. And then they'll give you feedback on where they think you are and the areas that you need to improve. Then if they are okay with the correction that you have made at this stage, then you can move to stage 2, which is the comprehensive audit that will lead to you being certified or given the certification. And then after that, you do some, if there is a corrective action that need to be done, then you will be given, and then thereafter you'll be awarded the certification. Then after 9 months, then the certification body will do what we call the audit follow-up to see whether you closed some of the actions, the corrective action that they had given you. And then they also start what we call the surveillance audits. So in brief, this what a project schedule for an ENMS can look like. It can be different, and the timelines can be longer than this. It depends on how prepared your organization is, or how familiar your organization is with the management systems. That's brings us to the end of the presentation. Below,
Thank you.
Those are the contacts detail. In case you need to browse the standards that I shared earlier, you can go to our web store using that link and be able to view the pricing and also the scope of those documents. Thank you.
Thank you so much, Mr. Alex, for your comprehensive presentation. We are very, very grateful. You have taken us through the energy management standards here in from the international perspective and also in Kenya. And we do have a couple of questions on the chat for you. Maybe I can just batch them, but the main question, I think you've handled it towards the end. Most people are asking where to get the standards that you have described to us today. And I hope maybe later on we'll post on the chat that link. Also, you can join our WhatsApp broadcast to get some of these links that the speakers are providing. Also, Alex, there's a question from Engineer Manyala, who is one of the mentors for our YEEP program, the Youth in Energy Empowerment Program. And he's curious to know on how many companies in Kenya so far have been certified with the ISO 50001 2018 version. I don't know if you have a response to this.
Yeah, I know at least 2 have already been certified. 2 others are in the process of implementing and seeking a certification. 2 others have inquired about the process of initiating. So the energy management system is gaining traction in the country, and we encourage other organizations and also other energy auditors. I think they can consider recommending this approach towards energy management.
Excellent, excellent. Also, maybe just to get your comments on, currently Kenya and Uganda have draft energy policy. For Kenya, it's the draft energy management regulations, and for Uganda, they have a draft energy policy. What do you think is the role of these standards while the national leaders are giving this kind of laws and regulation? Do you think the standards act as a catalyst to the energy efficiency agenda or as a hindrance? What is your thought on that?
My view is they act as a catalyst, because one of the key things that what determines the energy performance improvement is the quality of the energy audit. So if the energy audit is not done well, then you'll not be able to achieve the objective of an energy efficiency program. And how do you ensure that an energy or energy management is done in the right way? One way of doing is to have guidelines or some requirements which are normally defined in standards that guide the people that are doing that particular work, to ensure that people do work to almost the same level of the standard. So it's actually helpful, in my opinion, that way.
Thank you. Thank you very much. Maybe you can take one more question from Elvis. Elvis, I see your hand is raised. He is part of UNREA from Uganda. Would you like to pose your question to the speaker?
Good morning.
Morning to you.
Hello. Yes. Alex, thank you so much for the presentation. There's quite a lot that one can pick from that presentation regarding ISO 5001, the management system standard. However, I just had one kind of input in one of your last presentations, where you indicated, I think within 2 or 3 months, there was an element where you indicated that at this point in time is when you engage or even select a certification body. Now, from my experience, an organization will have no business with a certification body, not until the management system is fully implemented. Because in most cases, what certification body normally asks about 2 or 3 questions. 1, have you implemented your system to the fullest? 2, have you conducted at least 1 internal audit? And 3, have you conducted at least 1 management review? Now, again, this is a misconception from most of the clients that are implementing or require certification. Because at the point they need certification due to different reasons, they actually think that certification starts, or the process of acquiring certification starts with a certification body. The process of acquiring certification starts way back, as you have indicated in your presentation. But after you implement your system to the fullest, then there at that point, you'll have to engage a certification body. I think you can throw more light on this. Thank you.
Thank you, Elvis. Perhaps I need to clarify. I think that at that particular point, what I meant is the organization needs to start to think about the certification body that it will use to satisfy itself. And the rationale is this. Even at that stage, some CBs can help you conduct your gap analysis. So that one can be viewed as just a checklist of establishing where you are, for example. So some CBs will give you a form and accept, okay, even before you start implementing the system, for example, if you already have an environmental management system in place, then you can be able to check, okay, we already have this. For example, you have analyzed the context of the organization. We already have this one in place. So what else do we need to do? So that is the rationale of that particular point. And it's also crucial at that point to start thinking about, okay, which body will I use? And as you develop your gap analysis, then you'll know the gaps that then start implementing what is already not in place.
Thank you. Thank you so much, Mr. Alex, and for the audience for the questions for this session. We had a poll in the morning asking what are the barriers, and unfavorable policies and standards came in at a close second. And at the first barrier that the participants viewed to be the first one was financing, which I will now like to move on to our next speaker. If you have questions for Alex, keep them on the chat. We will handle more of the question and answer later, or if not, we will capture them in our reporting. And next, we now want to look at a new topic of understanding energy service companies, or how they are known now as ESCOs. And for this, we do have the perfect speaker. He has over 30 years experience in the energy efficiency space. He has helped co-found 3 ESCO companies, and he is an advisor. He has a wealth of experience in advising on investing in energy efficiency projects to governments, to corporates, and to generally businesses. In 2012, he founded Energy Pro, that is a company that is specializing in accelerating the investment in energy productivity and this agenda. And today he's here with us. He's also a published author with 3 books out, and he has such an interesting blog called Only 11% that you need to check out. His name is Dr. Steve Fowkes, and he's here with us. Welcome.
Well, thank you,
Great
Liz.
to have you today. Take it away.
Yeah, thanks. Good to be here, and thanks for the opportunity. And I am sort of constrained to leave at 12, but we'll get this presentation done, and we'll answer as many Q&As as we can. So,
Excellent.
Understanding ESCOs. I think ESCOs is one of those terms that everybody in energy efficiency hears, and people have a different understanding about it. I think it's widely used, but widely misunderstood. So hopefully today I can shed some light on ESCOs. So just always worth looking at history, I think, when we're trying to understand any subject, but history is terribly important. And does anybody, we should have had a poll on this, I'm sorry we didn't organize this, but does anybody want to take a guess, just kind of, we won't do it properly as a poll, but for yourself, what year do you think the world's first energy services company was founded? Either 1775 all the way through to 2001. You know, take a guess. Most people will be surprised. So the first ESCO was created in 1775 by James Watt, who of course invented a more efficient steam engine. He didn't invent the steam engine, he just made it more efficient. And his business partner, Matthew Boulton, and they created an energy service company in England in 1775, and they provided these efficient steam engines to pump water out of mines. And the way they got paid was they took a share of the savings in coal. So it just shows, you know, there's very few new ideas. And when people talk about ESCOs, their first one was in 1775. So just 200 years after that, ESCOs started to come to the fore and be talked about, obviously in 1973, and then again 1979, we had the oil crisis, and that really started talking about energy conservation, as we called it then. And from that point on, in the 70s and 80s, there was a growth of the ESCO industry. Here in the UK, for instance, had BP and Shell create energy service companies. And so when you see these big oil companies suddenly saying, oh, we're into green and renewables, they tend to go through waves in the 70s and 80s, and then they uninvested later on. In the 90s, you had a lot of utilities entering the market, particularly in the US and Europe. And you also had USAID was extremely good at promoting the ESCO idea around the world, and as well as energy performance contracts. And so in nearly all parts of the world, there are people who got trained by USAID originally and then created ESCOs, and many of those ESCOs are still small, and most of them have never really achieved the potential that they could. And then in the 2000s, everything went in reverse. We had Enron, which was actually an energy service company of sorts, collapse, and many of the utilities got out of energy services altogether. And then back in the 2010s, the utilities got interested again. It's funny how big corporates kind of go in waves like that. And we started to have new models emerge, and we started to have what's called super ESCOs appear, and I'll explain about super ESCOs in a minute. And now we definitely got more interest in the super ESCO model around the world. There are several in development. And also the really important point, for the first time in my career, you've had real increasing interest in energy efficiency from investors. They usually don't understand it, but they're really getting very interested in it. And we're starting to see the launch of more and more funds specifically to invest in energy efficiency. And it, through ESCOs is one way of doing it. So that's a quick history lesson on ESCOs. What's the business model? I think nearly everybody, or most people, have seen some version of this graphic where the ESCO develops and implements energy efficiency projects. It provides a guarantee of performance. It either brings or arranges finance. It usually does not finance things themselves, which is one of the myths around ESCOs. And the projects save money over the life of a long contract, and the savings are split in some way between the client, so they can save money from day one, repaying the capital, and ESCO revenue, which is used to maintain the savings and operate and maintain the plant. So that graph is kind of everywhere. Sometimes it has an increasing cost of energy, but that's the basic business model. So simple in theory, difficult in practice. So how big is this global ESCO industry? Helpfully, the IEA produced this a few years ago, and it shows that the ESCO industry globally is growing. It's now worth about $32 billion a year. Most of that is in China. The next biggest proportion being the US, then Europe, and the rest of the world. And what's important to understand and remember, putting China on one side for the moment, where there are a lot of single purpose industrially focused ESCOs, 90% of the revenue in European and US ESCOs are in the public sector. And one of the phrases, pieces of jargon that you hear a lot of talking of ESCOs, particularly in the US context, is the MUSH market, which is municipalities, universities, schools, and health. But most ESCO activity is in the MUSH market. So $32 billion a year, that's kind of okay. Just for comparison, I'll just put this up, 32 billion, Goldman Sachs as a company turns over 60 billion, IBM turns over 74 billion, and Exxon turns over 178 billion. So at the end of the day, for all of the attention that we pay to ESCOs and all of the sometimes obsession that people have about ESCOs, it's pretty small in a global scale, especially when you think about how much energy is spent and how much energy is wasted So really, it's a tiny, tiny little industry in a global sense. Okay, so what do ESCOs do? What is the role of ESCOs? First of all, they develop projects. Often they don't conceive of projects or originate projects, but they develop them so they can be built. They usually provide some guarantee of performance, which is what distinguishes them from a simple contractor. They build the projects. They can bring finance, often third-party finance, and they work to maintain the savings over the period. And repeating myself there, but they provide the guarantee. So that is a summary of the roles of ESCOs. At the end of the day, they are project developers and contractors. And a guarantee, whenever you have a guarantee for anything, the customer always pays for the guarantee somehow. And that's worth remembering. You don't get something for nothing. You don't get a guarantee for nothing. In these very complex arrangements that you often have around ESCOs, the client is paying, and sometimes paying a high price for the guarantee of performance. So if you're starting to think about ESCOs, you really have to think about what are you paying for the guarantee and how much is that guarantee really worth. So alternatives to EPCs, the EPC being end contract, which is the main contractual model that's talked about in relation to ESCOs. And sometimes they're called EN, and sometimes in the US particularly, they're called ESPCs, Energy Saving Performance Contract. But basically it's the same contractual form. And most ESCOs and most conversations about ESCOs are really about EPCs. So EPCs really do have a lot of issues. It's quite interesting having been around it for a long time and now getting this interest from investors, other people. Over the last 5 or 10 years, I've had lots of people who come at this from not knowing about energy efficiency or not knowing about ESCOs, often from bankers and financial people who suddenly say, I've discovered the energy performance contract and it's going to solve everything. It's the answer. We can lend lots of money on these energy efficiency projects. This is the way forward. But what they don't understand is some of the issues around EPCs. And again, EPCs can and do work, but if you're thinking about them, you have to think about the problems with them. First of all, they are complex. In any sort of industrial or commercial situation, the contracts can be very, very big. They take a long time to negotiate, so there's a high transaction cost. They are, by their nature, they have to be long-term because you're recovering considerable amounts of capital. So typically 7 years, sometimes 15 years, sometimes 20 years, sometimes longer. So long duration contracts are an issue, particularly in a world that we now live in where things change so quickly and all the things that you thought were certain are not certain. There's lots of issues around measurement of results, and we have measurement and verification, and we have IPMVP, but that still doesn't get around some of the measurement of results. And the recent events of the last year and a half with COVID have kind of shown that. It's like, if you suddenly stop using your building because of COVID, how do you measure the results? And how do you measure the impact of that as opposed to the energy efficiency measures? Huge, huge problem. EPCs have never worked well for the commercial sectors, partly because of this longevity, and the complexity makes it really hard. And also the commercial sector is more rapidly changing than the public sector. And they certainly don't work for SMEs because you've got this huge, great big contract. And then I think the final issue, I'm sure there are other issues as well, but the final issue is they don't actually bridge what I call the development gap. So the development gap is the gap between here's some potential energy efficiency, and here's a bankable, implementable project. Now, my friends in the ESCO industry will say, yes, 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 they do develop projects. And it's true, they do develop them from a certain point, but they don't really generally create those projects, originate and do the really early stage development, which is a high risk process. They like to develop projects when there's a go ahead to do them in the conceptual stage. So they really don't address that gap. So in summary, traditional ESCOs and EPCs are not the answer. Some people think they are. They're definitely a tool, but they're not the answer. And I think it's really important people get confused between ESCOs and energy performance contracts. We do need to be clear in our thinking about this. An energy service company is a company that's delivering a service. An energy performance contract is a particular type of contract. And there are lots of other types of contracts. But often when people talk about ESCOs, they're really talking about EPCs, and they're kind of conflating all of these things, or both of these things. And it's really important. The energy service company is a service company. The contract is a form of contract. And there are other forms of contracts other than EPCs. So yeah, they're often conflated. Here's some alternatives to EPCs, and you get this alphabet soup: ESAs, ESAs, MESAs, LAASs, and MEETs, a complete alphabet soup of potential contracts. So an ESA is an efficiency services agreement, a MESA managed energy services agreement, lighting as a service, and then finally MEETs is a metered energy efficiency transaction structure. Now, these are not, perhaps with the exception of lighting as a service, they're not as common yet as energy performance contracts, but they have a number of advantages and disadvantages compared to EPCs. I'm not going to kind of go into the ins and outs of each type of contract. That would be a long-winded and fairly dull kind of presentation, but the contract, and you can read up on these, lots of information out there about the different types of contracts. And if you talk about types, company in the US, Metris, which is worth looking at, they really pioneered this efficiency services agreement. Lighting as a service, there are lots of examples around the world, and of course lighting as a service has become possible because of the great gains from LED lighting. Companies like eLight, and the MEETs transaction structure, which is still very new, is promoted by a coalition, and so far has only really been applied in the US, but it has lots of potential. But my point is, there's more to ESCOs than EPCs. There are different types of contracts. All of them have pluses and minuses, and there's still room for innovation. We have not created the perfect energy services agreement for each particular type of situation. So that's always worth remembering. It's not all about EPCs. Okay, super ESCOs. So super ESCOs, again, a concept that's been talked about for a long while. Nothing really much happened on super ESCOs for probably a decade or so. Now it seems like there's a lot of activity and a lot of interest in super ESCOs around the world, and particularly promoted by the World Bank, which has had kind of successes in this area. So super ESCOs. So super ESCOs are the answer to some of the problems with ESCOs. Not all of the problems, but they do answer some of the problems with ESCOs. And interest is growing, and as they're coming to a country near you soon, I gather that the World Bank is working on several super ESCOs in Africa. There's already ones in the Middle East, which we will talk about, and some coming in Southeast Asia as well. So what does a super ESCO do? A super ESCO really develops projects at scale. It definitely takes more development risk than an ESCO, so it starts much earlier in the kind of process from origination to bankable project. It always uses standard everyday commercial ESCOs to do the implementation of projects. It's not necessarily implementing projects itself. What it does do is it imposes standards on how you develop and document projects, standards around technology choice. It always standardizes the way that the results are measured and verified. And it can do a lot to build capacity in the supply chain by training and working with the ESCOs and the rest of the supply chain to bring up their capacity. And it can also aggregate finance. And this is one of the real issues when we talk about energy efficiency financing. The projects are very small compared to the amount of capital that institutional capital likes to deploy. Again, energy efficiency projects often in the few millions to the tens of millions would be a very big energy efficiency project. Investor and a fund, you need to invest hundreds of millions. And so this Super ESCO can act as an aggregator of projects and arrange large quantities of finance. And the first, I suppose the first and most famous example of a Super Etihad in the UAE, which, as I always say, it's rather surprising that the UAE is teaching us about energy efficiency when you look at their energy consumption, but they really have pioneered this model with the help of Regional Bank and others, and are doing some really, really good work. And they're working with clients who have buildings. So they're contracting to carry out this kind of work across whole portfolios of buildings. They're not interested in doing, they're taking much more development risk, and they're really driving standards and building capacity in the supply chain. So doing many of the things that, as I say, address the problems with conventional ESCOs. So again, really worth reading up on what Etihad is doing and has done. So varieties of Super ESCOs, a bit like service contracts, there's not just one type of Super ESCO. You have the Etihad model, which is a Super ESCO, has to be owned by DEWA, the Electricity and Water Authority. It uses performance contracts, despite all of the problems that I've said about EPCs. It uses local ESCOs, and it really focuses on these big portfolios of buildings. The new one, or newer one, which is now up and running, is in Saudi Arabia. And this is modeled quite a lot on the Etihad one. It was set up with World Bank assistance. It's owned by the Public Fund. And again, it's using EPCs and local ESCOs, but it's really focused on the government estate, which in Saudi Arabia is large. So always hard to get much information about what's going on in Saudi Arabia, but it is up and running and implementing projects. And again, the two best examples, or the first examples of Super ESCOs are from the UAE and Saudi Arabia. Countries not formally known for their energy efficiency capability. And then another variety of Super ESCO is EESL in India. We have a partnership with EESL here, but so EESL operates in a completely different way to Etihad and Tarshid. It aggregates demand, so it works with local governments, industrial sectors, and it collects all of the demand for projects and puts them all together and implements them. It does not use energy performance contracts. It doesn't even use measurement and verification, but it is very good at implementing projects at scale, and it's publicly owned. Another example, an example from France, which is worth understanding, a company called, or an organization called SPL OSA, and it's a local regional Super ESCO, and it's owned by 10 local authorities who've come together, created it, funded it, and it really focuses on public sector buildings, so offices, schools, all of the buildings operated by the public sector in that region. And it's been very successful. It does use energy performance contracts, and it's implemented a lot of projects. So the idea of a local or regionally owned super ESCO is quite appealing, and I think we're going to see a lot more innovation in that area. And then final example is something that is like a super ESCO, but does it in a completely different way. And I've just thrown this in really as a good example about a variation on the model. And this is something called the Carbon and Energy Fund here in the UK. Rather confusingly, it's not actually a fund. What it is a procurement framework for National Health Service hospitals to procure ESCOs to do energy performance contracts. So it's a procurement framework that allows hospitals to actually move projects from here's a good idea through to here's an energy performance contract. And because it tenders the actual work out to a number of ESCOs that are on the framework, it is compliant with procurement rules. So again, it's sort of in that gray area. Is it a super ESCO? Yes, no, maybe. It sort of does the same things as a super ESCO, but in a different way. Okay, how does this all fit with energy efficiency financing? At the end of the day, we know we need to rapidly increase the amount of investment into energy efficiency. And a few years ago, I developed a little model of how we do that, which I call the jigsaw. And I know maybe some people have seen this before, but I'll go through it. And the first thing you need in this jigsaw is to provide finance. You need money to invest. Now, finance comes in two flavors. One is project development finance, and developing projects is always risky because you don't know whether the project will proceed or not. And then there's long-term project finance, which is when you have the project fully developed. Everybody, you know where the revenue is going to come in, you know what performance is going to be. Long-term project finance, there's lots and lots about that around. It's not high risk, it's low risk, whereas project development finance is high risk. And we need probably more project development finance because there's quite a lot of long-term project finance out there. We need people to bridge that development gap that I was talking about. We need to develop a pipeline, and I think that comes from several ways. We need more attractive business models, which is where some of these different flavors of energy service contracts like ESAs and lighting as a service come in. We need a better way of selling energy efficiency, consultative selling. People buy energy efficiency for multiple benefits, and the multiple benefits are much more interesting than just saving money on energy usually. And they're linked to the strategic benefits and the strategic direction of companies. We do need to build that development capacity, and we need to aggregate projects. You know, little, as I said, energy efficiency projects are really tiny compared to what investors need to deploy capital into. So we need to aggregate. We need to standardize, and that standardize the development process, standardize the technical solutions, and standardize contracts. Without standardization, you can't really deploy capital at scale. And then finally, systems, we need to standardize the systems, and we need to build capacity. And that means building capacity in the demand side. We need to make users and customers more aware of energy efficiency and more of energy services and what can be done with them. We need to build capacity in the supply chain, everything from vendors, equipment vendors, energy service companies, developers of projects. And we need to build capacity in the finance industry. And what's happening in the finance industry now is you get a lot of people saying, we like energy efficiency, we want to invest more in energy efficiency. How do we do it? Because they don't know anything about energy efficiency. Or they say, we want to invest more in energy efficiency, find me a project with some solar panels. You know, which to me is not energy efficiency. It's a good project, good thing to do, but it's not energy efficiency. So we really need to build that understanding. And I compare it to the wind industry, back in 1991, I was involved in some of the very, very first wind farms in the UK. And at that point, there were probably 5 or 6 bankers and 2 banks that understood anything about wind. And that was because they'd done things in the US. You know, you could literally put the entire wind industry in a small meeting room, and you put the number of investors and finance people who understood wind into a telephone box. There was nobody. Now there are hundreds, thousands around the world, and banks that fund wind have big wind teams, and they have lots of capacity and lots of understanding. And that's happened over 30 years, but we need to do the same thing around energy efficiency. So I think that's my little model of how you increase investment into energy efficiency. And I think the interesting thing about super ESCOs is they work on all 4 pieces of that jigsaw. And if we go back to my 5 examples of super ESCOs, Etihad, Telstra, ESL, SBL, OSA, and CEF, as we call it, they've all got different models. They've all got different ownership structures. They operate in different sectors and they have different financial sources, but they all deliver these 4 pieces of the jigsaw in different ways. And I think that's really important when you're thinking about either as a policymaker or as a company, how do you increase the flow of investment into energy efficiency? So it would be remiss of me not to mention ESCO in a box. I know that some people know about ESCO in a box. This is a thing that we developed. I said earlier that one of the problems of conventional ESCOs is they cannot possibly work with SMEs. The contracts are too complicated, the projects are too small, and the UK government had a competition to come up with new business models for how to address that problem. And we came up with ESCO in a box in partnership with Oxford Low Carbon Hub and Oxford Brookes, and was funded by BEIS, and with Chris Mabori and Innovators and Trevor from Enzo Impact and funding from GIZ, we're now deploying it in Kenya. So this is an alternative model, originally, as I say, designed for SMEs, and it's a licensable operating system, which is why we call it ESCO in a box. If you buy the license, you get the box, and everything you need is in the box. And the box contains this kind of startup package, a marketing package, standard contracts, partner support, an operation package, and links to sources of finance. And I'm sure if you want to know more, we'll be happy to kind of provide information, or Chris Mabori can talk to you about it as well. So that's ESCO in a box. And it really is a way, what we're finding here in the UK, and I think elsewhere in the world, it's the way of building energy efficiency capacity, which we need, but it's also more and more being seen as an economic development tool in some regions here, where people recognize the kind of economic development pathway has to include ramping up investment into energy efficiency. So where do ESCOs fit into everything? I said earlier, what we're trying to do is increase the flow of investment into energy efficiency. That is the central problem that I think we're all working on. And there's this massive pool of potential projects. You can go into any building, any industry, if you're an energy efficiency person, and you can find projects. I almost guarantee anybody on this call can do that. But what we don't have is turning that potential into real projects that then get invested in. Whether they're invested in by the company or by somebody else doesn't matter. It's just the amount of investment that we care about. And so we need to increase that flow of projects all the way from origination through development, through underwriting, financing, building, implementing, and operating. How do we do that? We need to build demand so people actually buy energy efficiency. And a lot of that is about selling the strategic benefits. There's also policy issues that can drive demand. There's prices, all those things obviously drive demand. We definitely need to build the capacity to develop projects, because we're still short on capacity to actually develop projects. and we need to build the capacity to finance projects. And finally, of course, we need to increase the volume of capital that is dedicated to energy efficiency. And that is starting to happen. Here in the UK, we now have 3 publicly quoted funds that are purely investing in energy efficiency, and a number of private funds as well. That volume of capital is going up, but you can have the capital, but if you don't have the capacity to develop projects or the capacity to finance projects, which means the technical skills to put together projects and bring money in, it doesn't matter how much money you've got. So you need all of those things to come together. That's my kind of systems view. And I think ESCOs are primarily around the capacity to develop projects. They can influence demand because they can go out and sell. They can influence the capacity to finance because they're interacting with finance. So they're sort of bridging that development with a bit of finance and a bit of demand building. I think if we think about super ESCOs can become much more involved in building demand, and particularly when they're selling to large portfolios and they're taking more of this early stage development risk. And they can get very much involved in building capacity to finance projects because they're interacting with institutional investors and presenting opportunities to deploy large amounts of capital rather than small amounts of capital. So they can help build that capacity. And then I think on top of that, you get this idea of dedicated financial sources or financing instruments. So that will be things like dedicated funds or dedicated credit lines, or other sources of money that are saying we definitely want to invest in energy efficiency. And that can influence demand, because if people know the money is there, they will go out and develop projects, can help build capacity to develop projects, capacity to finance projects, and build the volume of capital. So I think that kind of spreads. So ESCOs cover one part of this problem, super ESCOs a bit more, and then financial sources cover more of the problem. So I think it's really important to link those together when we're designing policies and programs to increase investment into energy efficiency. So final slide, really, in conclusions. ESCOs are and can be an important tool for increasing investment into energy efficiency. Absolutely. And sometimes people think I'm criticizing ESCOs or commenting, but I'm not. They can be important, but we really need to recognize what they are, what they can do, and what they can't do. And even after 40 years of people talking about ESCOs, they're widely misunderstood. I mean, I once jokingly said at an ESCO conference, if you have 20 ESCO experts, you'll get 40 different views of what an ESCO is, but it shouldn't be the case. We should be really clear about it. Typically, ESCOs don't do early stage development, and this is a big gap. This is how do you go from this massive potential to a real bankable project? We know the potential is big, the number of developed projects is small, and we need to bridge that gap, and that's a developer risk. It's an obsession with ESCOs and EPCs, particularly, that goes beyond what it should. As I say, recently I've been approached by people going, oh, I've just discovered EPCs. This is the answer to energy. And they're not the answer to life, the universe, and everything. They have their role and they have their place. EPCs, particularly energy performance contracts, have major problems: transaction costs, complexity, measurement, lack of flexibility, all those issues. And as long as you can deal with those issues and the customer can deal with those issues, that's fine. But you have to recognize that they're there. And that's a misprint there, but 80 to 90% of EPCs outside China, I would say, are in the MUSH market, the municipal, university, schools and hospitals. And that's because those buildings are generally stable. Local authorities are generally stable, or governments are generally stable. But even that is changing now. Here 10 or 15 years ago, if you were contracting with a local authority, you could be reasonably certain that the building would be there in 10 or 15 years. Now you can't, because even those organizations are changing much more rapidly, and their building needs are changing much more rapidly. And of course, with COVID, there's lots of changes about buildings and working from home and so on. It's really important not to confuse ESCOs and energy performance contracts. ESCOs are the company, energy performance contracts are the contract type. Let's be really clear about that. And other energy services agreements are available. So ESAs, MESAs, lighting as a service, MEETs, and probably a whole load of other acronyms we could invent. There's still scope to come up with new innovative energy service agreements that address these problems. And then super ESCOs, I think super ESCOs are a really interesting time. They can definitely fill the development gap. They can aggregate projects and they can finance at scale. And I think we're going to see more super ESCOs emerging in different forms. And some of those may be private sector super ESCOs. There's no reason that they have to be publicly owned. There's a kind of policy and capacity building argument for making them centrally owned, but there's absolutely no need why they should be. But they need to be able to take development risk. So that's my conclusions. There was a lot of stuff there. ESCOs, a really interesting area. Again, something energy efficiency generally, we've been talking about them for a long time. People think they're huge, but they're not so huge, but they do have big potential, and we need to kind of carry on refining the model and implementing it and working to solve these problems. Thank you. Happy to answer questions for 5 minutes or so, and then I will need to jump off on you.
Well noted. Thank you so much, Dr. Stephen, for that comprehensive presentation on ESCOs. For those who aren't aware, I'm sure we are now up to speed on what we need to know. It's very exciting here in Kenya to be deploying the ESCO in a box model. We even have the Youth in Energy Empowerment Program, the first cohort adopting this in their host site. It's very exciting to localize it to the Kenyan market and to the region. And maybe before you jump off, I can maybe just ask you, what you've given us such great insights from across the globe. What do you think is the potential of ESCOs in the African region? Are there any differences that will need to be adopted here? We do have policymakers and regulators on the audience. It would be excellent to hear it from you.
I think fundamentally the problems are the same everywhere, but obviously there's different stages of development. And I've just done a piece of work for the UN looking at this exact problem in the Arab region. And in the Arab region, you have different countries. Some are much more advanced, some are less advanced, some have more technical capacity, some have well-developed financial markets, some don't have well-developed financial markets. And basically, what I'm saying is the pieces are the same, but some of those pieces you need to kind of be on this side of the scale to that compared to that side of the scale in different countries. But you still need the fundamental problems. And the fundamental problems are, how do you develop projects? How do you develop the capacity to finance them? And of course, where does the finance come from? But if you build that flow of projects, finding the finance is relatively easy. It's not simple. So I think fundamental problems are the same, but you need to adjust the model. So and what I said in the Arab study is, in the countries with less well-developed financial markets, you probably bigger proportion of public activity or public sector activity than you do in the more developed markets like UAE, for instance. And also, we should never forget that the government everywhere has a bigger state. And I think governments have a role in promoting this model as a way of putting their own house in order, because we know we can go into hospitals or government buildings and find lots of energy saving opportunities that are not exploited. And that could be a really good way for a country to help build capacity. Start with the government estate, use it to train people, build capacity, prove the model, and then it could spread.
Thank you so much. We still have about 5 minutes. We have extra questions on the chat. Hopefully I can batch them and then you can answer collectively. There's one asking on that most African energy companies, particularly in East Africa, face a challenge to win international energy bids. Is it because we have poor company standards and policies? And then there's one curious about the ESCO situation in the region, legal framework, and how it compares to Europe. I think this you have answered. So maybe it can be on the first question around how do we angle ourselves to benefit from financing?
Yeah, I think standardization is part of it, and we've done a lot of work on standardization in development ways. I mean, one of the problems from energy efficiency financing, whether it's ESCAs or not ESCAs, is when you're an investor and people come up with an energy efficiency project, even if it's an LED project, which is like really simple, it's the simplest project you can have, you will look at 10 LED projects from 10 developers, and they will be developed and documented in a different way. And you're an investor, and you actually don't know much about energy, and you don't know much about LEDs, and you certainly can't do. And you're looking at this and going, which one do I believe? This one has done it this way, this one's done it another way. That's a real problem for investors, and particularly when you start to scale, because the reason banks and financial institutions can scale things is that they are very standardized. If you go for a loan from a bank, let's say it's a loan to buy a house or a loan to buy a car or a scooter or whatever else, that's completely standardized. If it wasn't standardized, they couldn't do it. It's like every mortgage application or every loan application was a whole different form or everything. So standardization is pretty critical. Banks are factories. They like standards. You can't operate factories without standards.
Thank you so much for that. You have given us the idea that Africa does have a huge potential to benefit from ESCOs, and especially the model that is now getting deployed in Kenya and in Africa. So to those who are curious about the ESCO in a box model, we will post a link to it, as Innovators is currently working in partnership with Energy Pro on driving this change. We hope to go regional soon. So for those who are curious, we're going to, please free to join our WhatsApp chat, as we'll give you more links to that, or even we'll post on the chat now. To you, Dr. Steve, such a pleasure to have you here today. Absolute grateful for your insights. And for those curious about his contact details, please do join the WhatsApp broadcast, and we will share this with you. Thank you so much.
Okay, thank you, everybody.
Session.
Thank you, Liz. Yeah, and I will drop off as I have to go to India now. So, all right, talk to you later. Thanks. Bye.
Okay, bye-bye. Thank you. Absolutely amazing. To the audience, thank you so much for sticking around. We promise to give you trends on energy efficiency and the technology updates, and that is what we are looking at. We even have we're even seeing that the financing models, we need innovation around that as well. So we are now coming to the next session. But before then, let us have a quick icebreaker to sort of stretch and juggle our mind a bit. And at this moment, I'll kindly ask Emily to share the screen for a short icebreaker. Let us all view the screen and tell me as it's coming up. Oops. Okay. Just give her a bit of time. Excellent. So it's just a quick test. And I want us all to look at the screen and count the number of faces you are seeing and post on the chat. This is going to be a timed session, so we're not going to leave it on for too long. Feel free to post on the chat the number of faces that you are able to see. I'm going to let this run for a bit. Are we still counting or Googling? Okay, 10 seconds to go. 8, 7, 5, 4, 2, 1. Everyone seems to have the same answer of 10. Emily, you can now show us the answer to this challenge. Yesterday we had John Nganga win the activity. He got it right. And let's see how many of us saying 13, 11. Some people will explain to us their numbers Emily, you may go ahead and share the answer. There we go. It's a total of 10. Is that 10? 10. Oh my goodness, we had so many winners today. I am not sure if the time was too much that people Googled, but the people of 13 and 12 will just have to explain to us how they were creating their own faces. It's excellent for those with 8 and 9. Thank you for that challenge. Thank you, Emily. Thank you for the audience in participating in this one. We now take a quick break, a quick coffee break, 5 minutes. It's 11, it's exactly 11 East African time. Let us just take a 5-minute break. Then after that, we have a session with an IEPA trainer. He is going to focus on a topic that accounts for about 70% of energy consumption in industries. So it's very, very exciting. Do not log out. You can just have your video off for the 5 minutes. And then at 11:05, we log in. Okay, great. And welcome back from your break. We are still on for this webinar, Technology Updates in Energy Efficiency. Absolutely amazing to have you stick around with us. We now move on to our last speaker for the day. He is a trainer with IEPA. We had said that IEPA is the Institute of Energy Professionals in Africa. And the next person, this speaker, if I were to highlight the initials, all the certified courses that he has done, next to his name, we have Certified Energy Manager, Certified Energy Auditor, Certified Measurement and Verification Professional, Certified Water and Efficiency Professional, Renewable Energy Professional. He has such an experience on all things energy efficiency. He is also a certified trainer with IEPA, and he is here with us today to look at efficiency in motors with a specific attention to IE4 and IE5 motors. Ladies and gentlemen, Mr. Albert Williams, hello. Hi, Albert, are you able to hear me? Okay, just a moment. He seems to be still on the break. But as he comes on, we are going to focus on motors in the next topic. And maybe I can just quickly look at the chat on pending questions that may have not been addressed. We will have the WhatsApp. We'll post information on the WhatsApp broadcast on the chat where you can join in and have all the presentation and links to the speakers on the chat. And you will gain access. We also want to encourage all the stakeholders here to join in on the World Energy Day celebrations and activities that are year-long and in the run-up to October, where we are going to Kampala, Uganda. We do have sponsorship packages for this, and I hope my team will be able to post a link to the website where we do have previous reports on roundtables, we have packages, we have other events such as the innovation for the Youth Challenge, where last year we had winners from Cameroon, Zambia, and Uganda. That was our winning trio. This year also we will have an innovation challenge. We will also have last year we also had the Energy Professional Awards for the first time that was focused on East Africa. We also had a lot of winners from Uganda and Kenya and from across the globe. So look out for all these activities, and it will be great to have you on. Thank you, Ruth, for posting the chat as we await on our next speaker. We also encourage that for those who are joining us, that you may rename yourself to your actual name so that it's easy to call you out. It's just, you can just go onto the chat and find your name, go to more, and then rename to your actual name. And as we wait for our speaker, maybe I can call on Chris. There was a lot of interest on the ESCO model, ESCO in a box model. Maybe you can just comment on this as we await our speaker. Chris, are you there?
Yes, please. I'm there.
Excellent.
Yeah, quite good. I just want to first thank everyone for participating in this. And we appreciate, taking your time to just come through to this. So we've been working with lots of players, especially to try and develop the ESCO model, especially in this part of the world. As from Stephen Falk's presentation, you could tell that there's still a lot more to be done, especially in the Africa space in developing this ESCO model. So we've worked with Energy Pro and GIZ to just develop this ESCO in a box model. And what it is, it's just a pack of everything that ESCO, which is an energy service company, would need to develop a bankable pipeline. So you have a starter pack, for example, or how you set up your company in terms of going for the projects, having maybe a customer relationship management system that can help you manage your customers who you want to execute these energy efficiency projects. But it also looks at how you go into developing the reports. For example, the technical part, how would you go to develop maybe a desktop analysis report, a feasibility report, an implementation report. So you have all that support, but you also have you know, the legal documents, which is kind of a very big part in the ESCO process and complicates a lot of things. And if many of the ESCOs that are formed do not have these you know, legal documents that are required to execute this model. So the ESCO in a box model brings all these together so that it just makes it easier for you. And it's not only about the documentation, there's also the partner support, you know, that you're getting when interacting with, you know, other entities that have already executed a lot of this. It also brings in that aggregation of projects, because you can have a lighting project, but if you're 10 different ESCOs in the region that have all these lighting projects, you can bring them all together and have a sizable ticket for execution. So it's a model we are already doing here in Kenya, and we are looking into expanding to Uganda, and also just seeing how can we use this to support all these other different countries in Africa. There's also a lot of interest from South Africa, and a few more from the western part of Africa, like Ghana and Nigeria. So this is something we look forward to working with interested ESCOs to just see if we can deploy them with the aim of implementing more energy efficiency projects in our region, and also deploying capital in these projects. Yeah. Thanks a lot, Liz, for the ambush. Yeah.
Apologies. Thank you so much for coming right through for that sort of ambush, and it's also really great. We do have the Youth in Energy Empowerment Program, whose banner I am donning today. They are with us today, and we are taking them through some of these templates, as Chris has mentioned, from the desktop analysis. Such an interesting process to see, and as Dr. Falk had mentioned, is that we are trying to standardize that whole process, where if you want to go through the whole energy efficiency process, you have an immediate box, or sort of a box of documents. We're calling it the ESCO in a box model, and you have the model right there. It's very suitable for SMEs in the UK, but here we want to see how we can adopt it for even the industrial clients as well. It's interesting because even Uganda, the UNREA have a whole member association focused on energy efficiency and energy auditing. I would like now to check on one of the, it would be interesting to listen to one of the youth that I'm talking about. It would be nice. I'm just talking on and on about the Youth Empowerment Program, and it will be great to listen to one of them. Let me see who we have. Hi, Cheryl. Would it be possible for you to just join us and give us a brief experience so far? Oh, I think they're now shy. Albert, would you like to join in? Ooh, they're now practically running off. It's interesting. However, it is okay, however, since it would have been nice to listen to one of them. We are still waiting on our speaker. It would be interesting. Oh, hi. Hi. Is that Albert?
Yes, it's Albert.
Excellent, excellent. Thank you for joining in. Maybe you can just give us a brief of your experience so far with the YIP program, especially on the ESCO in a Box model, the templates that we are working on now.
Okay, so first of all, I want to talk about my YIP experience so far. It's been a great learning experience. We've been privileged as the first cohort to learn and get the opportunity to exercise, to know the essentials of energy audit and especially energy efficiency. So as at now, we are in the internship level where we are applying the skills that we've learned so far in the energy efficiency and energy audit. So as Liz has mentioned, we've been developing the ESCO in a Box model for our various sites. And it's been a great experience because we are now putting into practice what Dr. Steve was mentioning, as well as Chris. So for me, I can see that it's a great, or I can say it's a great modern model to enable energy efficiency and energy management in the various industries. And I believe that as this is a new thing in this region, that is going to push these projects to a greater height. So as for us in the YIP program, we are still developing these projects, and this training has been a great way of getting us to understand deeper and know the nitty-gritties of ESCO. So thank you, Chris and Dr. Steve, for that insight.
Thank you so much. We are still following up on the speaker. He is with us. He just dropped off and experiencing a bit of technical challenges, but he will be joining us. Maybe you can listen to someone else. Gideon Omangi, he is in a host site in Nakuru. Gideon, would you like to just give us your brief experience so far? Hi. Hi, Gideon. Maybe you can just unmute and proceed to give us a brief. Are you on mute? Okay.
Hello.
Hi. Yes, we can hear you now. Maybe you can just give us a small brief.
I have network issues, but I'll share what we've been doing since we began. So first of all, some of the guests that have been presenting have been our teachers and mentors, and maybe you've gotten a small experience of what we've been learning so far. It has been a lot of wealth of knowledge and information, and we are really grateful that we have been given the opportunity to implement the ideas in industry and enable them to be energy efficient. And also, we have been empowered with skills that have helped us share that information with the industry that we are working with at the moment. It has been awesome, and we are progressing to become good energy champions. Thank you.
Thank you so much, Gideon. It's great to hear from you. And as we wait on the speaker, I don't know if I see Esther Nyanzi, who is with us. She is the CEO of UNREA. I don't know if she wants to say a quick hi to us. Esther, are you there? Okay. But it's a real pleasure to have her join us today. It's a great partnership we have with UNREA. It's absolute amazing. Just as we wait on the speaker, we can just have a quick call to action. Oh, hi, Esther. Are you able to speak? Apologies. I think it's we can see you, but it seems your audio is off. Okay, maybe she will join us a little bit later. So for now, maybe we can have a small icebreaker video as we wait on the motors session. Emily?
We are constantly being bombarded by problems that we face, and sometimes we can get completely overwhelmed. The story of the hummingbird is about this huge forest being consumed by a fire. All the animals in the forest come out and they are transfixed as they watch the forest burning, and they feel very overwhelmed, very powerless, except this little hummingbird. It says, I'm going to do something about the fire. So it flies to the nearest stream, takes a drop of water, and puts it on the fire and goes up and down, up and down, up and down, as fast as it can. In the meantime, all the other animals, much bigger animals like the elephant with a big trunk, could bring much more water. They are standing there helpless, and they are saying to the hummingbird, what do you think you can do? You're too little. This fire is too big. Your wings are too little. And you're big, so small. You can only bring a small drop of water at a time. But as they continue to discourage it, it turns to them without wasting any time and tells them, I am doing the best I can. And that to me is what all of us should do. We should always feel like a hummingbird. I may feel insignificant, but I certainly don't want to be like the animals watching as the planet goes down the drain. I will be a hummingbird. I will do the best I can.
Indeed, this is the call to action. We are asking us that on the energy efficiency agenda, that us be like the hummingbird and be willing to make the change. It's exciting news. The speaker is able to join us now. He had dropped off a bit, and I had introduced him earlier, but it would be great to just mention him again. Albert Williams, he is a certified trainer with the Institute of Energy Professionals in Africa. He trains on several courses. We even have some coming up. It will be great to post that link on the chat. He trains on certified energy manager courses, the certified energy auditor. He's also a UNIDO qualified trainer. Hi, Albert.
Hi, Liz. How are you?
Hi. I am good. I actually sat for one of your exams on the UNIDO's Teams optimizing session, and we are still beefing and having a grudge at how the exam was, but it is great to have you today. Thank you for joining us. Take it away.
Okay, thank you, Liz. Yeah, sorry, I was just running back from breakfast. I thought I'm starting at 12 o'clock. But yeah, I am. Okay, so can you see me? Can you see me good? Everything fine?
Yes, we can see your slides. Maybe you can just place them on presenter mode, and we are good to go.
Right, there we go. Okay, so you can see my full screen. Am I correct?
Yes, yes, excellent. Thank you.
Okay, thank you. So welcome everybody. Welcome. Regards from Egypt. I'm here in Cairo. We're busy with some compressed air training this side, and also we're busy with the industrial efficiency on motors program for UNIDO. So it's a great privilege to be here. I would have been yesterday, but I couldn't make it. Friday is normally a weekend here in Egypt. So I can bring you some updates on motors and some of the new technology, things that have changed in motors in the recent years. And motors are really a industry that is rapidly evolving. Every month, there's new things coming out. There's new technologies because of the electric vehicle market. The electric vehicle market, the research and development is really driving motors, and we see a lot of exciting new things happening in motors. And you know, if I do this presentation in a month or two, there will be different things already. So it's one of the fastest evolving markets. So let's start at the basics. So why do we use motors? Okay, so a motor on its own cannot exist. If I have a motor and I'm switching it on, nothing is going to happen. I have to connect a load to this motor. So I have to connect a pump or a fan or a compressor or a conveyor to this motor for me to get some work out of my system. So motors cost money to install, to maintain. That's quite expensive. And I'll show you the life cycle cost of motors just now, how expensive it is to operate a motor over a 10 or 20 year life cycle for this type of motor. So we really have to look at how we are consuming energy in motor systems. Just giving you a little bit of a global perspective, motors consume a lot of energy. If you look at industry alone, 2/3 or 67% of all industrial energy goes to motors. But if you look at the global electricity consumption, we see that 40% of that goes to driving motors. Now, if you take that 40% and you break it down into the loads that we are driving, we get pumps, fans, compressors, conveyors, and we're sitting with about 22% for pumps and 18% for compressors. So that's the breakdown of the applications that is being used, or the things that the motor is driving. So this is just to look at some industrial electricity usage in motor systems, and in what different kinds of sectors you will find motors. So the chemical, pulp and paper, iron and steel, these sectors are quite intense with regards to the consumption of electricity in motor systems. I did some research on the IEA website. They published, every now and then they publish some new information, a very nice source of information. So the IEA said that there is our total energy supply globally, 166,000 terawatt hours. You can go through those numbers there. The global electricity consumption is 24,000, and then we're sitting with 10,000 terawatt hours, which is about that 40 or 42% for industry. And then motors consume, as I've said, 2/3 of that. So we're sitting with 7,000 terawatt hours. Compressors consume 22%, 18%, and pumps consume 22%. And if I look at the average electricity tariff, we have 150 billion euros per year going to pumps. So that's a lot of money that is being used to drive pumps, compressors, fans, and conveyors. Now, the IEA also did a study, and they said if you're going into the average industrial facility, you can save 26%. So in any industry, 26% of energy is available to be saved at an economically attractive rate of return. Now that represents 39 billion euros per year. So there's a lot of money available. There's a lot of work. This last week in Egypt, we've been traveling throughout the country, going to different facilities, and I can assure you there's lots of energy that's being wasted. Even the companies that is certified, ISO certified, and that has got a very clean record. Even in these companies, if you look below the carpet, you see a lot of dust and a lot of wastages everywhere. So there's plenty of work for us as energy efficiency engineers to do. The work will never dry up. So these are some things from the Association of Energy Engineers, some studies that Dr. Eric Woodruff has done. Some of you will be familiar with his work, just to show you how attractive energy efficiency projects are. Now, and Chris and Bori can also emphasize this and support these statements. And he's also done some lot of work on these kinds of studies. So the Dow Jones Index, basically, if you invest your money in energy efficiency, 8 out of the 10 years, your money will perform better than in the stock exchange. And on the right side, there's another example that the stock price of companies have increased by 21% after a notification that they are going to do energy management projects. So the thing I want to emphasize here is that energy efficiency is very attractive. It's an undersold topic, and there's really attractive opportunities out there in industry and also commercially. And there's another paper that says here that you can save 31% in addition to the energy savings. So it's not only about energy savings, but we improve productivity, we reduce maintenance. Some of these soft topics also has a 31% additional saving beyond the pure energy savings. So I hope you are supporting me that energy efficiency is really attractive from a financial standpoint. And I know some of the previous speakers have also talked about the financial aspects. Looking at this is just an example of a compressor versus a normal vehicle that you purchase. And if you look at the 5-year life cycle cost, where does your money go to for 5 years? For a compressor, 88% of your life cycle cost will go to the electricity cost of that compressor. The purchase price is relatively small. Compare that to a vehicle where the energy cost is actually quite low in comparison with the purchase price. And look at this statement at the bottom here, which is very interesting for me. An induction motor can consume per year an energy quantity equivalent to 5 to 10 times its initial cost along its lifetime of 12 to 20 years, representing 60 to 200 times its initial cost. So, ladies and gentlemen, you can agree with me that it's worth it to spend a little bit more on your motor, as 60 to 200 times, the energy will be 60 to 200 times as much as the original procurement cost. When we are looking at motors and motor systems, we are looking at the systems approach. We're not only looking at the motor or at the component. As I've said, the motor cannot exist on its own. We have to look at the drive, at the pump, and at the entire system. On the left here, we've got a motor with a 91% efficiency. But if we zoom a little bit out and we look at the motor driving the pump, we see that the combined motor plus pump has a 59% efficiency. And now if we zoom out even further, you can see there's a valve that is almost completely closed. And we use that to throttle the load of the pump. And now the system efficiency is 13%. So if you only look at motors and we only think about the technologies and improving the motor to a higher class of efficiency, we are actually missing most of the savings. So that's why we're doing the systems approach. We look at the pipes, the valves, the control mechanisms, how the water or the air or the steam is being used, rather than only looking at the motor. And here's another very nice example. Look at the top picture. We have input power of 100. Let's say it's 100 kilowatts. And we have some losses over the motor, over the shaft, or if you have a belt, then there's a pump and a throttle loss. So on the top picture, we've got all these losses and we end up with 31 kilowatts of output. Now, if I improve some of these components, if I improve the motor and the coupling, and I get rid of the friction in the pipe, and I look at the motor, the pump, how that is operating, I still get the same output, but my input power is much less. Can you see I go from 100 kilowatts down to 43 kilowatts? So what have I essentially done here? I have gotten the same output, but the input power has been massively reduced. So what I've created here is a virtual power station. Now you can spend a lot of millions or billions of South African rands that we have been doing to build some power stations, or you can create these virtual power stations. So these virtual power stations, we are creating energy to have energy security in the country, and we can now improve the economy and use the energy elsewhere to grow the economy. As we know, Africa, there's a decoupling between energy efficiency and economic growth. We cannot reduce energy at the same rate at the expense of the economy as some of the first world countries can do. So that's a very cheap way to create energy or to create a power station. Right, so we are looking at the systems approach. If I look at the systems approach, I can save anywhere between 5 and 40%. If I only look at the motor, maybe 1 or 4% can be saved. So I have to start at the load requirement first. First, look at the valves, the pipes, the pump, the fan. And then after you've optimized that, then you go to the motor. Okay, but most of you or some of you may be aware of all of these things if you've done some of the CEM or CEA training courses. So let's go a little bit more into the details of motors, electric motors. So we get 2 classes. I'm not going to go too technical or in too much detail here, but we have direct current motors and alternating current motors. On the alternating current side, we've got induction, 3-phase induction motors. Those ones are the most common and by far the most popular ones. Then you get synchronous as well. And on the DC motors, some of the new and emerging technologies is the electronically commutated permanent magnet motors. And I'll show you some things on these technologies. So firstly, we've got this 3-phase induction motor used in more than 90% of electric motor systems. We've got very good reliability. It's low cost relatively. The maintenance is quite easy. It's easy to control. So these ones are very popular and you'll see them everywhere in industry. Then we have this permanent magnet synchronous motors or PMSM. They are also called electronically commutated motors or brushless motors. So the advantage of these types of motors is that they do not have brushes. Now, brushes is one of the components that wears out the fastest and that has a very high maintenance cost and a replacement cost. So we've got this advantage of no brushes in this permanent magnet types of motors. The other advantage is that we've got synchronous operation. Okay, so if you're familiar with motors, you know that the rotor is rotating at a slower speed than the magnetic field that's being created. So with these types of motors, the rotor is rotating at the same speed. So that's just some technical. The thing that we have to focus on here is that there's 20% less motor losses, right? Not the improvement in efficiency, but the motor losses is reduced by 20%. So these motors are becoming very attractive. At this stage, they are quite relatively expensive, but as we go into mass production, especially with electric vehicles, the cost for these types of motors will come down. And as the magnet cost is also coming down, these things are going to become more popular. So if I talk about the motor losses, what types of losses do we talk about? I'm not going to go into the detail, but basically you've got electrical and magnetic and mechanical losses. And there's the different kinds of definitions. You can have these training material afterwards, and you can go through these types of materials or some of these losses that you find in motors. So what is the efficiency of these electronically commutated motors in comparison with your normal induction motor? And here's just some efficiency curves. And basically, you can see that the permanent magnet motor or the EC motor has got improved efficiency over the different kinds of ranges, but it's only for small applications, less than 8 kilowatts. So there are just a little bit of a comparison between these types. And here's just an overview. I'm just giving you a little bit of a concept of where the different kinds of motors are being used, for what types of sizes they are being used for. And the induction motor there is the most common one for a wide range of different sizes. So the failures in motors one of the biggest failures is because of bearings. And bearings can fail due to, firstly, overheating. All right, overheating is one of the largest problems in motors. If you are going, if you increase the temperature of a motor a little bit more than its capacity, the motor lifetime is going to reduce quite rapidly. Other things there is the insulation breakdown, mechanical breakage, and electric faults. So just to come back to that temperature, on your nameplate, you will have a different insulation class. Normally a class F is quite a common type of a motor. And this gives you a operating temperature of 155 degrees Celsius. So if you operate your motor at 165 degrees Celsius, you will reduce your lifetime by 50% if you have that motor. So temperature is extremely important to improve your insulation lifetime and also your bearing lifetime. So the moral of the story is use the correct motor for the correct application based on the conditions. Other things that influences motor is frequent starts and stops, because that increases the temperature, voltage unbalances, environmental conditions, and operating the motor harder than it can handle. If you operate it at a higher kilowatts than it's designed for, you are going to reduce the lifetime. Okay, so the topic of this conversation I'm having with you today is to look a little bit at the motor efficiency classes, IE1 to IE5. So these are the international energy efficiency standards that has now been accepted worldwide. Previously, they had the EFF 2 and 1, but these things have now been overruled to these IE1, 2, and 3 efficiency classes. And I'll give you some more information on that. So then that's a big saving. You also get an IE0 motor. For instance, in China, they will manufacture IE0 motors and they will sell it to Africa, because in China, it's illegal to have anything less than an IE2 motor. So we have to be careful for the types of motors that we procure. So what is the efficiency, or what is the benefit of these high efficiency motors? And I've listed some of the advantages here. Firstly, it runs at a cooler temperature. It has an extended lubricant life. The bearings are better. We are less susceptible to rewinding. It's less influenced by power quality problems and harmonic problems. Phase imbalances is less as well. And we have less I²R losses, which is basically the heat losses. So there's not only an energy saving going from an IE1 to an IE4 motor, for instance, there's also all of these maintenance savings. And that's why we are really emphasizing to spend a little bit more money in purchasing the higher efficiency classes. There's just an overview of what are some of the manufacturing aspects in designing or in building some of these high efficiency class motors. You can have a look at that at a later stage. So there's the international standards that's being used these days. So we've got the International Electrotechnical Committee, and they've got different standards to define the classes of efficiency. So here we've got IE1 to IE4 classes of efficiency. Now, commercially available only goes to IE4. There's an IE5 as well, which is your ultra efficiency motor. Now, these things are not really commercially available. It's more of a concept at this stage. As the technology is improving, these things will be rolled out and be more available. So it's only presented at this stage as an informative annex, Annex A in this IEC standard. So the goal of an IE5 motor is to reduce the losses by 20% relative to IE4. So, and that's the difference. If I can, okay, I'll show you a little bit later, but all of the efficiency classes basically has a 20% reduction in losses. So from IE2 to IE3, there's 20% less losses. And that's sort of the criteria for these efficiency classes. But IE4 is commercially available and easy to procure. What are some of the differences in terms of efficiency? There is the 5 curves for motor efficiency. over the range of its power. And we've got a 20% reduction in each of these classes. Now, the efficiency classes have been standardized. So the IEC is used in Europe and basically in the rest of the world. Then the USA are using the NEMA standards, which is the National Electrical Manufacturers Association, NEMA. But NEMA and IEC is very much integrated and they are very much the same at this stage. But we are using IEC classes. So how do they determine these efficiency classes? Firstly, they have to test it at a certain torque and at a certain rated speed. So at 100% torque and 100% rated speed, they do the measurements and they compare the efficiency at that point. And that is how they categorize these different kinds of efficiencies. Okay, so this is the IEC 600-34-30-1. Now there's also an other type of a standard. It's a 61800 standard from the IEC. And now they are looking a little bit more at a bigger picture. We are looking at the entire motor system. In other words, it's not an efficiency only built into the motor, but the variable speed drive is also taken into consideration. Okay, so we've got the efficiency classes for the entire motor system. If you look at the left here, we've got the motor, the basic drive module, the auxiliaries, and the feeding section. So that whole system there is what that's being determined by this efficiency standard. If you look at the right side, there's basically 8 points where they have to test this motor to see what is the efficiency difference. So firstly, because they have to take into consideration that this motor will not always run at 100%, but some of the times it will run at part load conditions. So we've got 100% torque, sometimes at 50 or 25%, and at different revolutions per minute of that motor. So they take a cross section of different kinds of operating parameters to have a fair apples to apples comparison on these efficiency classes. So that's a very nice standard to look at because the variable speed drive is taken into consideration. So what is a super premium motor? IE3 have at least 15% less losses than an IE2. The super premium IE4 has 15% loss difference in relation to IE3 at least. And then this new IE5 class will also have a 15%, at least 15% loss in relation to the IE4. Now, if we look at induction motors in industry, we go up to IE4 class. But in the last few years, there's been a drive in electric vehicles. And if you have a look at a little bit of the history, especially in Europe with regards to the policies, all the motor manufacturers are spending a lot of money. They are seeing that electric vehicles are the way of the future, and it's being outsourced in most European countries quite soon. So in a few years' time, normal vehicles will not be manufactured anymore. So Audi, BMW, Mercedes, all of them are doing a lot of research and developments to improve the efficiency of motors. So as all of this money, and this is the first time in history that motors are increasing with this steep learning curve, or the technology is changing at a rapid pace. So that's why the IE5 is becoming more prevalent. As this technology is changing, the induction motors will be outphased in the future, and we will have more permanent magnet type motors, and also with variable speed drives. So quite exciting the things that's happening in the electric vehicle market. Now, I'm sure in the audience there's some policymakers or some people from government that has some influence over the national policies of your respective countries. Now, this is actually quite an important thing. This is the approach coming from governmental to determine what is the efficiency standard for different countries. So we have the MEPS, the minimum energy performance standards, and a lot of countries, basically all the first world countries already have this implemented. Basically, it says that you are not allowed to procure any motor of a lower efficiency. That is what is shown here. So, for instance, in 1997, the USA and Canada said that all motors shall be IE2 motors. And here's a timeline for all kinds of different countries that have implemented this as well. And India had it in 2017. So this is quite important. And this is one of the biggest drivers towards improving energy efficiency from a governmental perspective. Because I'm in Egypt now, we are sort of talking about this, and I'm more familiar with the Egyptian situation. Egypt has now, just last year, became the first African country that has adopted a MEPS standard for their motors. And they have now said that all motors shall be of an IE3 efficiency class. So currently in Egypt, if you look at the top right picture there, most of the motors in Egypt is currently an IE0 with very poor efficiency. And they've got IE1 and 2 as well. But Egypt has got the capabilities to manufacture IE3. So government has said, no more, we shall not import these lower class efficiency motors. And Egypt is now becoming one of the leaders with regards to energy efficiency. So that's really an example for the rest of Africa to follow Egypt. Here are some of the countries that has determined, that has dictated these classes. And you can see all the first world countries already has gotten these performance class requirements. And look at the bottom there, just because of this policy that Egypt has adopted, they will save $560 million by the year 2030, just because of this law. And the first time I've been doing these motor training systems, it was in 2014, and they said that anytime now the South African government will also adopt IE2 minimum energy performance standard. That was 8 years ago or 7 years ago. Still today, South African government has not determined or did not sign off this policy, and it's not yet adopted in South Africa. And it's really a simple concept. I understand there's some supply chain problems and some logistical concerns, but government really has to look at this, and it will make a massive influence, because 2/3 of all energy in industry goes to motors. So if you can adopt this, you will have definitely a large improvement in your national electricity consumption. And yeah, like I said, the Chinese especially is manufacturing these low quality motors, and they are exporting them to Africa. So Africa is their market for their poor quality. So Africa is sitting with the inefficiencies. Right, and here's just some information on Egypt, the things I've just mentioned, that we will save $560 million by the year 2030. That's very interesting. If you are in a position of power like that, please consider, if you have any influence, to get some of these policies going. We really need it as Africa. We are lagging behind versus the rest of the world. All right, so we've talked about the motors. Just quickly on the transmission, we have to convert, or we have to transfer energy from the motor to the pump or the fan, and we've got different kinds of technologies here. We've got gears and belts, and it's also something to consider. Different kinds of gears, there's some pictures there. And then belts are more common in industry. 1/3 of all transmission applications uses belts. And you can consider by changing, if you have, for instance, a V belt, you can convert that to a flat belt or to a synchronous belt, and you can get some percentage of savings there. There's some comparison. Look at the efficiency of V belts versus cocked V belts or synchronous belts, and you get some efficiency savings there. So also something, automatic tensioning of belts is also a consideration to improve, remember, your motor system. We're looking at the holistic picture. Just some maintenance things. Look at the belts, replace them if needed, replace the pulleys if needed. Look at the belt tensioning, have automatic tensioning if possible, and you can get some savings. Don't forget about belts. We always talk about motors and pumps and compressors, but sometimes the belts are forgotten about. Here's some pictures with a thermal camera. You can look at, on the left side here, we've got the belt. The belt is not properly aligned. The tension is not correct. And you can see there the temperature of that belt because of all of this outwearing of the pump because of the poor alignment. And on the right-hand side, we've got some temperatures there on the bearing side, and that's also because of misalignment. It can be because of vibration. The bearings are starting to fail, and those excessive temperatures indicate that the motor is about to fail and it needs desperate maintenance. Right, some new technologies, other things to think about if you are having electric motors is regeneration. If you have a motor or a hoist or a crane that is picking up a load, if it's picking up a load like the left picture there, you are going to use some energy. But as soon as that load is being delivered, or as it's going in the downwards direction, we can think about regeneration. We can use a variable speed drive with an active front end, and we can basically generate electricity and feed that back into the supply network. All right, and that's what some of the technology in Formula One motors, for instance, when the cars are braking, instead of having a frictional brake, they've got these active front end brake, and they are basically generating energy to make the cars more powerful. So whenever you have some technologies like a crane or a hoist, something to consider. On the right-hand side there at the shipping port, they've got this types of technology. It's basically a variable speed drive that you can regenerate some of the energy. Right, so the mechanical brake is having a lot of frictional losses, but with this dynamic brake, you can have an electric circuit that allows the energy to be dissipated through a resistor back, and we are creating energy. Very nice. Think about an application like this, or consider something like this. We were yesterday at a steel manufacturing facility here in the east of Egypt, next to the Suez Channel, and we saw some of these massive overhead gantry cranes that are picking up these ladles in the steelmaking industry. So yes, with installing the VSDs with regenerative capabilities, you can save up to 40% of the energy consumption. Elevators as well to consider there. Let's look at a little bit at the case study. There's a retrofit. All right, we're going. This was an actual case that was done in Egypt. They went from an IE0 motor to a IE4 line start permanent magnet motor. It is only a 5.5 kilowatt, so it's a relatively small motor, a 4-pole motor. There are some of the information on the specifications of these motors, and you can have a look there. But basically, the original motor, the IE0, was oversized. It ran at a load factor of 57%. So we could have actually reduced the size of the motor as well, but the plant were not comfortable with that, and they kept the same size for some redundancy. But by replacing that, only going from a induction motor to this line start magnet motor, they were able to achieve a saving of 1,500 kilowatts per hour per year with a 2-year payback. So it's a very small motor. There's case studies that's more attractive than this one, but it's just a little bit of an indication of how much money you can save. All right, so just as one slide, what to do with your electric motors? What are some of the opportunities? First and foremost, look at the end use. Look at the pump, the fan, the compressor, the conveyor. How are you consuming this water or air? After you've done that, then you can consider right-sizing the motor, control your motor with a variable speed drive, upgrade, if you have low efficiency classes, upgrade that to a higher efficiency. Consider replacing your induction motors as the cost is coming down. Keep your eyes open on these technologies as it becomes more commercially available. Power quality study. If you've got harmonic problems and power quality problems, you can consider a study on that. Maintenance, conditioning, monitoring, and your transmission system also has to be considered. All right, so that covers the motor side. Just a little bit on the load. We said we are looking at the load where energy is finally being consumed. Just a few slides on this. Once again, the big losses is in the driven equipment. A motor on its own is useless. It's only when it's driving a fan or a pump that we can get some work out, and that's where the opportunity is. So we're not going to go into this pumps and fans. Basically, we've got training courses for this. The Certified Energy Manager, Certified Energy Auditor focuses a little bit more on these aspects. Basically, your pump or your fan must be operating at its most efficient point. It must be of the right size. So you have a certain load or a certain requirement for air or for water, and the pump and the fan must be correctly sized and correctly operating to satisfy that demand. So there's a whole 5-day training course on how to do that. And we're going into some software when we do these pump training courses and fan training courses. Control, control, control. Do not control with closed valves or through bypasses or through closed dampers. Consider having a variable speed drive. There are some limitations to that. There's not only just put a variable speed drive and it works, you have to think about some aspects there. Pumps in parallel is always an opportunity. And then pump suction conditions. The pipe on the suction side where the water goes into the pump, oftentimes there's problems there. And I'm saying that 80% of pump problems are in the piping or in the distribution, and 80% of distribution problems are at the suction, and you get cavitation as well if those conditions are not proper. We want to increase the pressure on the suction side of a pump. And for fans as well, fans, there's a lot of commonalities between fans and pumps. But for fans, it's quite important that the dirt requirement, that you have the correct type of fan for the contaminants in the airstream. And also you have to run at your best performance curves there. So we just had some case studies. I just want to show you some of the things. I did a project in Albania on the pumps for a water utility. And there's this, they've got a 300 kilowatt pump, 2 of those ones, consuming 4.6 gigawatt hours per year. And we find a lot of friction in the pump station. One of the things we found was that the discharge valve was 40% open, 60% closed. And we found a variable speed drive on the wall there, but it was been decommissioned because no one knew how to work it. So on the right-hand side, there's the picture of that valve that we found was 60% closed. By opening up that valve and by commissioning the variable speed drive and by upgrading the motor to an IE3 motor, we were able to save 240,000 euros, a 42% saving just by doing some simple aspects. Simple payback, 0.1 years. On compressed air systems, this is where I do most of my work, is in compressed air systems. I've personally done a study on about 60, between 60 and 70 energy systems that I've audited. And my findings were that there's 9 areas of opportunity in compressed air systems. Compressed air, very, very expensive. For every 6.7 kilowatts that goes into a compressor, only 1 kilowatt comes out. So 6.7 goes in, only 1 kilowatt of pneumatic power comes out. And that 1 kilowatt, 50% of that is wasted. So you're sitting with a system efficiency of 5 to 10%. Compressed air is the most expensive source of energy. So by looking at things like how your compressors are controlled, what is the storage volume in your system, looking at leakages and inappropriate uses, looking at the pressure in the system, these things can save you quite a lot of money. And my findings, if you look at the right-hand side there, my findings were that you can save, oh, it's not there, but the savings were 36%. a 36% saving in an average industrial facility at the 81% return on investment. Extremely, because it's so inefficient, a small saving, if you can stop a small leak, you get a massive saving because of compressed air being so inefficient. Very exciting, and I've seen a lot of wastages just yesterday on we were at a textile manufacturing facility. I've got literally hundreds of these case studies. There's just one on a textile because I'm working in textile these days. So there's just an example where we improve the control, we improve the storage volume, and we manage the leakages. So it's a relatively small system, this one, but we found a 40% saving with a payback of 9 months. And there's on a steam system as well on the same textile plant. We saved, 4%. Just by doing some easy things there. All right, just some case studies. This was in an Egypt textile company, also on compressed air. This is one we did this one in March in Egypt, and we saved 21% with an 8-month payback. So there's lots of things on compressors as well. All right, so let's wrap up. I'm almost finished. Let's look at some of the emerging technologies. Electric vehicles, very, very exciting. And I've read some books and I've looked at some presentations and conferences. Electric vehicles are the way of the future. They are coming in rapidly, especially in Europe. These things are becoming quite prevalent. And self-driving vehicles also is much more advanced than I thought. There's really some interesting studies and some testing going on. But right, okay, so with electric vehicles, it's quite efficient. We've got much less parts, moving parts. The maintenance is much less, and the energy conversion is much better efficiency. So from generation, but it all depends where the electricity comes from, how you are charging your battery. If you are charging your battery with coal-fired power stations or with gas-fired power stations, you negate all of the savings that you are really making. So it's good if you can get the generation from renewable energy sources. But at the end of the day, much less losses in the energy path of an electric vehicle. And if you have regenerative braking as well, that puts back some of the energy. Here are some of the different kinds of motor types. We've got induction motors in the first column. There's the power density, the cost, the reliability. So the Tesla S and the Tesla X made use of this induction motor technology. And then they went over to permanent magnet technology. And that was the Toyota Prius, the Nissan Leaf, the i3 used these types of technologies. And now the Tesla 3 with this integral permanent magnets have come out with a high power density. You can basically pull away faster than a Lamborghini with the Tesla 3. Controllability, reliability is quite high. So these are some of the exciting things happening in electric vehicles. And we saw some of the things in Uganda, right? So well done to Uganda, which has rolled out electric buses. And there's some of the 245 kilowatts. They can go up to 300 kilometers on a single charge. So Uganda is some of the leaders in this technology. I saw in Alexandria in Egypt as well, they are doing some testing on electric vehicles or electric buses in Alexandria. So Uganda is really an example for the rest of Africa in this regard. All right, so that is the end of my presentation. Thank you, everybody. Thank you for your time. And I hope you learned something about electric motors. It's really exciting technology. Yeah, if you do the CEM training courses, they update every year or so. There's also a training course I'm involved with, is the Certified Industrial Energy Professional Training course, which is more focused on industrial applications, which also has a little bit of more information on motor systems, also on pump fans and compressor systems. So you can also consider that one. So yes, very exciting technology. There's training. You can contact me if you have any more questions as well. So thank you for your time. And
thank you.
Let us hand back. Thank you.
That was absolutely brilliant. Thank you so much, Albert Williams, for the comprehensive presentation on motors. I'm sure the audience has truly had a lot to learn from it. It's very interesting. There's a lot of questions on the chat for you. And I would like to point out, oh yes, we do have a comment from Ghana mentioning that they do have a minimum energy performance standard. It's just that it's not yet passed into law. And maybe I can just tie it back to what you had mentioned about China and the sort of the leaders of this trend already implementing these policies for their countries. Do you think that, what do you think is really hindering Africa's implementation of policies? Because I believe that we do have, as you've mentioned, even in South Africa, that they had an interest of implementing it, but somehow we do draft the policies, but the implementation doesn't fall through. What do you think is the main hindrance?
Yeah, well, I'm not really sure. I think there's people in the audience that's much more in a position to answer that than me. I think at this stage, it's all about costs. You know, I think a lot of us are in survival mode. You know, we are not having the luxury to purchase expensive equipment because we just want to survive until tomorrow. The economy is struggling in a lot of countries. South Africa, we are struggling. So the things are so cheap from China. And, you know, it's all about life cycle cost. The procurement department, the financial department, they are only concerned about the end of year figures. The stakeholders are only looking at this year's financial position. So we are really looking at just getting, we just want the motor, it has to work, and we don't really think about the electricity cost. And that up to 200 times over 20 years, you're going to spend on energy. So we are looking at purchasing the cheapest and easiest one. And China is just flooding the market with all of these cheap motors. I know Nigeria also, they've got quite a lot of these kinds of motors. So I think it's awareness, probably awareness. It's just, you know, we just want to get something in, it has to work. And that's sort of an industrial mentality in industry. Get the things in, get it working. And we're not really looking into the future. There's not a 10 or a 20-year horizon in our decision making.
Thank you so much for those comments. We do have in the audience people from the regulator in Kenya. It would be interesting to have them be in the audience to have understood our topic today on the policies, on the role of policies in improving motor efficiency. Just another question on, it looks like we have global leaders who are setting trends and Africa has to sort of catch up to them. What do you think Africa can do to sort of have our own localized trends that work for us, become our own trendsetter in the energy efficiency space? What do you think is unique to Africa that we can set a trend for the rest of the globe?
Sure, that's a difficult question.
Okay.
I'm not sure, you know, a lot of the technology is already out there, you know. I think a lot of times we should be careful to, you know, trying to reinvent the wheel and trying to do our own thing. The things are available. We just have to adopt. I think we first have to adopt some of the things and get to a certain position before we try to be innovative. But I think the advantage that we have in Africa is sort of, in a lot of countries, the bureaucracy is a lot less. You know, if you're in Europe and you're trying to implement something or get something signed off, it's such a hassle to go through all of these points. You know, in Africa, a lot of times it's much easier. We want something, we make one phone call, we get a signature, and it's in there. If there's no corruption involved, it will work good. But in South Africa, we have lots of corruption. But I mean, in Europe, I think in Europe, that's a big problem. In countries like Australia as well, the guys are so specialized, they're only doing one thing. They don't always have a holistic view of everything. So I think that's an advantage in Africa. We are not so constrained by procedures and steps to follow. So I think we must use our flexibility. So Africa is much more flexible and adaptable. You know, yeah, we've survived. If you live in Africa, you must be able to survive in tough conditions. I think that's our advantage.
Excellent. So resilience and flexibility is our advantage. Thank you for that comment. There's a lot of appreciation on the chat, a lot of thank yous for the presentation. Just like to highlight Simbarash's comment. He's asking if Africa can take the advantage of having manufacturing our own motors so that it might be easier to implement some of this minimum energy procedures. Is it something you think is hindering Africa? We sort of looking to China and importing all this?
I think so. I know Egypt is manufacturing, they've got the capabilities to manufacture IE3 motors, and South Africa as well, but it's like a lot of motor manufacturers is based in Africa, but it comes from Europe. So yeah, we've definitely got the capabilities to manufacture these things. Yeah, I'm definitely not an expert on what goes on in all the countries. I just know in Egypt and in South Africa, we've got the capabilities to do that. It must just be accelerated. But yeah, more than that, I can't really comment on too much. But definitely, and that's a problem. If we can manufacture it ourselves, locally made products, that will definitely stimulate the market much faster.
Mm-hmm. Mm-hmm. Thank you so much for that. A lot of appreciation on the chat. We really appreciate your presence today. We will share more of his contacts on the WhatsApp broadcast for those who are asking. We shall follow it up on the WhatsApp broadcast. Thank you so much, Albert, for that. Apologies, I see there are a few more questions. Sorry, yes, there was one from Patrick Cunha asking, do you have a standard reference table one would use to compare motors and the IE4 for the purpose of quantifying the savings? And there's another one on what are the efficiency value changes between IE1 to 5? I think this is mostly questions on resources, on what you have.
I think if you consult the manufacturer, a lot of manufacturers, they've got a brochure on the different classes, and you can see there for different kilowatt sizes, what are the efficiency increases from IE1 to IE4. Right, IE5 is not really available as yet from the commercially, but you can have if you go to a manufacturer's website, they should be able to give you a brochure of all their existing motors, and you can see at 100% load factor, 75 or 50% load factor, what are the improvements in efficiency and also in power factor. So consult those ones. Each manufacturer is a little bit different. It depends if you've got a 2-pole or a 4-pole motor. There are some differences in that. In my presentation, I had a efficiency curve. Patrick, you can also use, and also for John Marie, you can also have a look at that table as an indication. So I think the best is to consult the manufacturer's brochure. You can just go on the internet, you'll be able to find that from the main manufacturers.
Thank you so much for covering those comments. One last one, and then we can, John Mary, you have a question on, have you had a scenario where you preferred implementation of a VSD 4 motor system versus installation of an IE4 motor? I think this is just comparing between which is better, installing a VFD or replacing the whole motor with a more efficient motor.
A scenario. So, well, it depends on the application that you are driving. So VSDs oftentimes are a good solution, but it's not always the solution. I find that a lot that suppliers or salesmen come into a facility and they say, install a VSD and all life's problems will be over. Now you have to be a little bit careful for that. In some situations, a VSD is going to consume more energy. If you are putting it on the wrong pump, or a pump with a high static head, for instance, in other words, you've got a high elevation to overcome with the pump, then a VSD is not working. In compressed air systems, if you have more than one VSD, if you have got more than one VSD compressor, you are also wasting energy and money. There's a certain application for VSDs. A VSD, if your motor is running at more than 80% load factor, a VSD is not as efficient. A VSD is more of an application where your load is between 40% and 80%. So if you have fluctuating requirements, for in this hotel where I'm staying now, sometimes the hotel is fully occupied, sometimes it's only 20% occupied. So the HVAC system has to throttle up and down continuously. So for changing demand, a VSD can be that's the application for VSDs. But just be a little bit careful before you implement a VSD. It's not always the correct solution.
Excellent. Thank you so much for handling the questions and the comments. I think it would be more prudent to even post some of the links and the calendar of courses that IEPA AEE is having this year. We also have innovators who are working with the IEPA, and we will as well post links to upcoming trainees that you can join in and be experts. Albert is one of the trainers with IEPA. It has been an absolute pleasure to have you here today. Thank you so much. I hope Egypt is kind to you. It's exciting for joining in today. And now Albert had mentioned Uganda as a trendsetter in e-mobility. And as I mentioned, we have partnered with UNREA to bring forth this training, and they are here with us today. And it will be exciting to listen to Elvis, who is part of one of the member associations. UNREA is an alliance of member associations, and one of them is focused on energy efficiency. Elvis, if you're there, it will be great to have a few remarks from you.
Hello, good afternoon.
Good afternoon, welcome.
Thank you, Liz, for moderating these sessions. I'll apologize, I'll keep the camera off. My internet is not very stable, so apologies in advance. I bring you greetings from Uganda and Kampala, to be specific. My name is Elvis Sekate. I'm the Vice President of the Energy Efficiency Association Uganda, which is the Association of Energy Engineers chapter for Uganda. Here representing Madame Esther Nyanzi. Madame Esther Nyanzi is the CEO of UNREA. UNREA is the Uganda National Renewable Energy and Energy Efficiency Alliance. Being an alliance, it has 6 members. One of them is the Energy Efficiency Association Uganda, Uganda Solar Energy Association, Hydropower Association Uganda, Wind Power Association, Biomass Energy Efficiency Technologies Association, as well as Uganda National Biogas Alliance. So those are the associations or entities that do subscribe to UNREA. Now, UNREA and Uganda at large, we are very much excited to host the World Energy Day here in Kampala from 20th to 22nd of October this year. I remember towards the final bend of the World Energy Day 2020, we just had a loose chats with Chris as well as Caroline at the World Energy Day Secretariat, that why don't we have the next World Energy Day in Kampala? And I was pleased on this note. I want to extend my sincere appreciation to the World Energy Day Secretariat for considering Kampala as the next destination for the World Energy Day climax. We are greatly honored, and as UNREA and other partners within Uganda, we promise that we'll give it all our best to ensure that the World Energy Day climax meets the expectations of all the interested parties. As we know, the World Energy Day is going to run on the theme Energy Sustainability in Africa, unlocking the food sustainability, climate change, and water equation. There's somewhere I read that some of the challenges, the top 5 challenges in the world for the next 5 years, will be energy, water, food, among others. And when you look at them, the top 5 all have an element of energy in them. So ideally, we need to step up our efforts to manage our energy efficiently. And on that note, I would like to thank all the presenters in the last 2 days. They've done a good job to actually articulate issues to do with real-time monitoring, energy efficiency in motors, energy efficiency in piping, and the last presentation from Albert. I actually appreciate Albert's in-depth understanding and articulation of energy efficiency when it comes to compressed air, pumps, and even steam and other pressure vessels. So thank you all presenters for ably representing and ably articulating these issues. Actually, to an extent, I actually felt that I was in a CEA class because of the content that actually was presented in yesterday and today. So thank you so much. We look forward to having more of this and bringing more stakeholders here in Uganda on board to actually participate and be part of these World Energy Day events. Thanking the partners, e-innovators, among others, for putting this together. And last but not least, the World Energy Day Secretariat, Carol and the team, Caroline and the team, you're doing a good job. And Liz, please thank you and keep it up. And with that, I beg to submit. Thank you.
Absolutely. Thank you. Thank you so much, Elvis. You have all heard we are Kampala bound in October. We are heading to Uganda. They have electric buses. We need to join in and move on to and change the what is it called? The venue to Uganda. It is very exciting to have them as partners of World Energy Day 2021. So as of you've heard, we're in high gear for this year's conference. It will be an absolute pleasure to have you all join in. We will have the sponsorship packages are up. We'll post a link to our website on the chat. Feel free to also join our WhatsApp broadcast to never miss any updates on future events and on previous reports, presentations, and links. Also, for a big thank you to the participants for attending this 2-day training that started off yesterday. There will be certificates for attendance for both days. There will be e-certificates that will be sent out to your email later on. And also we had an activity today and we weren't able to pick out a winner because so many of you had the answer. However, we scrolled through and found that Patrick Kinyua was the first one to give the right answer. So Patrick Kinyua, to you, you are our winner for today's session. You shall receive a branded merchandise from the World Energy Day Secretariat. A big thank you to everyone who has joined in. It is such a pleasure to have you with us. So we still have a lot of events related to World Energy Day that will be in the run-up before the conference. We have these roundtables, we have trainings, we have the Youth Innovation Challenge that will be happening this year. Last year, we had the inaugural Energy Professional Awards. So there is still a lot that is up for grabs. We would love to have you join us in all these events. Looking forward to having you all. A big thank you to the speakers today. A big thank you to you, Alex Mboa, who joined us today. We've had such insightful conversations, and we cannot wait to see you in the next one. And with that, it's a wrap. We normally enjoy jazz music here, so you are free to leave.